Imagine this before there was soil beneath your feet, before there was even a concept of feet to speak of. There was only the dark and restless vastness of space, a kind of infinite waiting room, with no walls and no clock on the wall to tell you when something might happen. Out here, dust and gas float for ages upon ages, so patient that even eternity might glance at its watch and sigh. And then, like a shy conversation starting in a silent cafe, these particles begin to drift toward one another, slowly at first, but with the quiet certainty that something, somewhere, wants them together. You don't hear any cosmic fanfare, there's no drum roll, just an invisible gravity reaching out its hand, pulling one speck toward another, and then another, until a little swirl forms, not much bigger than a daydream. You let yourself drift closer. What you see is almost absurd, chaos behaving as though it's in love with order. Each fleck of matter moves as though it knows where to be, colliding, sticking, breaking apart, and returning again. Somewhere inside, you realize you're watching the prelude to a planet, our planet, but it doesn't look like Earth. Not yet. It's just a luminous soup of molten rock and metals, glowing with the sort of heat that could roast every marshmallow on the planet's future camping trips all at once. The temperature? Think volcano, but meaner. The surface? A writhing ocean of magma, with no coastline to define it. If you tried to stand here, your shoes, socks, and all philosophical concerns would melt into nothing in less than a blink. And yet, even in this unforgiving place, there's beauty. The molten swirls curl and fold into each other like oil paints mixed by a clumsy but passionate artist. Science tells us this was about 5 billion years ago, give or take, because scientists still debate exactly how fast the early solar system came together. Some argue that the process took millions of years. Others suggest it happened shockingly fast, like an impatient chef throwing ingredients into a pot. Either way, you're here now, floating just above the blazing surface of proto-Earth, watching it spin faster than you'd expect. One day back then lasted only a few hours. Imagine the sunsets if the sky wasn't a churning haze of vaporized rock. A stray thought slips in. Without this violent heat, without these chaotic beginnings, there would be no gardens, no mountains, no sleepy evenings with tea in hand. You realize how absurdly grateful you are for something you could never survive touching. The collisions are constant. Big rocks slam into the surface with the subtlety of a bowling ball dropped into a wedding cake. Each impact releases enough energy to vaporize oceans if oceans existed yet. And in a way, they are the planet's sculptors, shaping its size, its density, even the tilt of its spin. It's violent, yes, but not mindless. You begin to think of it as construction work, the noisy, messy part before the walls go up and the paint goes on. Some of those impacts bring gifts, heavy metals that will sink into the core, water-bearing minerals that will someday reign as oceans, even carbon, the backbone of life's eventual chemistry. Others bring only destruction, peeling away layers in catastrophic splashes of magma. But destruction and creation here are not opposites. They're dance partners who never stop moving. As you float above this restless world, the scene is hypnotic. The sun glows in the distance, weaker than you're used to, its light filtered through a dirty orange fog of dust and steam. Somewhere deep in the molten belly of this infant planet, iron and nickel begin to gather, pulled inward by gravity's invisible insistence. That spinning, molten heart will one day become the Earth's core, the very thing that shields the planet from the solar wind, the thing that lets oceans and forests and coffee shops exist. You're watching the heartbeat form before the creature is even born. For a moment, you think of all the quiet evenings humanity will spend on the surface above this fiery heart, completely unaware of the molten guardian below their feet. It's humbling in the way stargazing is humbling. You're not the center of the story, but you get to be here for the story, and that's enough. There's a strange comfort in knowing the Earth didn't begin as a polished jewel. No, it was clumsy, messy, even dangerous, and yet, from that unpromising chaos, every green leaf and gentle breeze will eventually emerge. If the universe is capable of turning molten stone into cherry blossoms, Maybe there's more room for hope than we sometimes allow ourselves. Somewhere in that thought, your breathing slows. The heat of this young planet no longer feels threatening. It feels like a blanket you could wrap around yourself. You let your mind drift with the slow spin of the Earth to be, letting the violent collisions fade into a distant, rhythmic thud, like the heartbeat of a world still in the womb. You're still floating above that restless newborn Earth, but something has shifted. The chaos is settling just a little, and you can almost sense the planet taking a deep, molten breath. The surface is still a violent ocean of magma, but now, deep below, gravity is whispering to the heavier elements. Come closer. Sink. Become the center. It's strange to watch iron and nickel behave like socialites at an exclusive gathering, pulling away from the lighter rock and diving toward the heart of the planet. You can't see it directly, but you know it's happening. Streams of molten metal sliding downward, pooling together into a blazing core hotter than the surface of the Sunday. If you could reach down through the magma, your hand would pass through layers like a cosmic cake, the lighter silicates drifting up, the heavier metals plunging down. Scientists call this the differentiation stage, and it's one of those underappreciated moments in Earth's biography. Without it, you wouldn't have a magnetic field, and without that field, the sun's radiation would strip the atmosphere bare, faster than you could say goodbye picnic weather. Some researchers still debate exactly how quickly this happened, whether the core locked into place in a geological blink, or whether it took millions of years of sluggish churning. Either way, this was the moment Earth built its most important invisible shield. Above, the molten seas bubble and churn, releasing great plumes of gas. It smells, if smell is even the right word, like every rotten egg, volcanic vent, and overcooked broccoli in the universe all at once. That's sulfur, carbon dioxide, and other gases, the breath of a planet still finding its voice. You drift lower, close enough to feel the slow, ponderous roll of convection currents, beneath the surface vast loops of molten rock circulating like thick soup in an invisible pot. These movements are the planet's first murmurs of geology, the earliest hints of the tectonic dance that will someday rearrange continents like pieces of a giant puzzle. There's a temptation to think of this as brutal work, but here, brutality and beauty are inseparable. Every time the molten crust cracks, liquid rock gushes out, glowing like fresh forged gold before cooling into jagged, glassy plains. Even from above, the fractures look almost deliberate, as though the Earth is sketching the outlines of future coastlines in a language only time will translate. For a moment, you imagine standing here, though you wouldn't last long enough to brag about it. The ground would be soft, shifting under your feet, and every step would leave you sinking into something that hisses and spits like a frying pan. But perhaps you'd see the horizon shimmer with waves of heat, and beyond them, towers of vapor reaching toward a sky the color of rust. The young sun, still a touch dimmer than it will be later, hangs in the haze like an ember. Its light glints off pools of cooling rock, turning them into mirrors that warp and twist with each ripple of molten movement. It's not the kind of beauty you'd put on a postcard, but it's hypnotic in its own alien way. In quieter moments, when no asteroids are slamming into the surface, you can hear the slow groan of the planet's interior, as if the Earth is testing its joints for the first time. Somewhere down there, the spinning core is already sending out magnetic ripples, faint and newborn, like the first attempts of a singer clearing their throat. It strikes you that this stage, the core forming, the planet settling into layers, is a bit like a person figuring out who they are. Before the forests, before the oceans, before even the first bacteria, the Earth had to decide on its own inner structure, and once it did, everything else could build on that foundation. You think about how often that's true in your own life, that the unseen, internal arrangements determine what's possible on the outside. Odd fact? This early molten Earth spun so fast that a day may have been just 4 or 5 hours long. Imagine how exhausting that would be. Sunrise, lunch, sunset, bed repeat 6 times before dinner. Over time, the moon's pull will slow this spin, stretching days into the more manageable 24-hour rhythm you know now. But for the moment, the planet is whirling like a dancer, who hasn't yet realized they can pace themselves. The impacts haven't completely stopped. A stray chunk of space debris still crashes through the haze now and then, splashing molten rocks skyward in fiery arcs. But each new blow grows rarer, and the Earth's surface, though still unstable, is slowly becoming less like a boiling cauldron and more like a crust with personality. You linger in this strange, glowing twilight, letting the sight of a forming world seep into your mind. The heat radiates upward in steady waves, and the magnetic heartbeat from the core hums like a distant lullaby. You're watching the Earth become itself, and for now, that's all it needs to do. The molten crust beneath you is restless, shifting and cracking as if impatient for the next chapter. You hover just above the haze, and then, without ceremony, the sky begins to weep. At first, it's not the kind of rain you know. These droplets hiss and vanish on contact with the still hot rock, bursts of steam spiraling upward in ghostly shapes. You realize you're witnessing something monumental, oceans being born from the sky. It's almost comical how the delivery works. Part of the water comes from within, released as vapor from the cooling magma below, rising through volcanic plumes and condensing high above. But the rest? That's the unexpected gift of 1 billion years of cosmic door-to-door service. Comets, icy asteroids, and water-rich meteorites, flung in from the far edges of the solar system, crash into Earth's surface, breaking apart and spilling their cargo. Each collision is both violent and generous, like someone throwing bricks through your window only to leave bags of groceries behind. At first, the water can't stay. The planet's heat flashes it into steam before it can cool, sending it back into the thickening atmosphere. But slowly, as the surface cools, think hot skillet left to sit in the evening air, the balance shifts. The steam begins to condense faster than it can evaporate, and then, one day, or maybe over 1,000 years of days, it tips. It rains without stopping. Imagine the longest downpour you've ever experienced, and then multiply it until the thought feels ridiculous. Weeks, months, maybe even centuries of falling water. Rivers form where there are no valleys yet. Waves crash against coastlines that don't exist. Pools swell into inland seas, which merge into sprawling oceans, the first blue patches in a world that has never known the color blue. The sound is constant, millions of raindrops hammering rock, hissing into steam, and the occasional distant thunder of an impact still arriving late to the party. You think of every calm ocean view you've ever seen and realize it all began in this deafening, endless storm. Scientists still debate the exact proportions, how much of our water came from deep within Earth's mantle versus icy visitors from beyond. Some argue the majority was homegrown, released by volcanic outgassing. Others suggest that comets were the real rainmakers. Either way, the result is the same: a planet draped in shimmering oceans, their surfaces reflecting what little sunlight filters through the still, heavy skies. And it's not just water filling these basins, it's a chemical cocktail laced with minerals leached from the newborn crust, stirred by waves and warmed by volcanic vents. This is not your friendly modern seawater, perfect for summer swims. This is the briny soup where the recipes for life will someday be tried. From up here, you see the first hints of what we now call the hydrological cycle. Heat from the molten rock still rises, turning patches of ocean into mist that swirls back into clouds, only to fall again as rain. Over time, this constant recycling will sculpt landscapes, carve channels, and grind mountains into sand. But right now, the water simply fills every hollow, patiently waiting for the next step in the planet's design. The first oceans are not peaceful. Winds rip across their surfaces, whipping up waves the size of skyscrapers. Lightning forks down into the dark water, and in those brief flashes, you glimpse the white spray and churning depths. It's a little terrifying, but also, if you let yourself admit it, comforting, because you know what's coming next. You know that one day these violent waters will cradle coral reefs, fishing boats, and the quiet hush of moonlit tides. Odd fact for the evening: if all the water on Earth was smoothed out evenly across the surface, it would cover the planet to a depth of about 2.7 kilometers. That's like submerging the entire world, under a layer deep enough to drown the tallest skyscrapers. Of course, it isn't evenly spread. It gathers in basins, pools around continents, and leaves deserts dry, a patchwork only time and tectonics could design. As the storm begins to ease, you notice the air has changed. It's cooler now, denser, almost breathable, though you'd still keel over from the lack of oxygen. The skies are a darker blue than before, and here and there, holes in the clouds open just enough to reveal the Sunday. Its light dances across the water in long golden streaks, making the oceans shimmer as though they already know they'll become mirrors for sunsets. You hover there for a while, letting the sound of the waves replace the roar of the storm in your mind. The earth has gone from molten chaos to a world with seas, and for the first time, the horizon feels calm, but deep below, the crust is still restless, and the next chapter is already stirring. The storms have eased, the oceans have settled into their basins, and now the earth begins to cool just enough to form its very first skin. From up here, it looks like a fragile crust of bread baking over a pot of molten stew, dark, cracked, and thin in places where the heat still surges through. This is the planet's earliest crust, and though it looks stable, you can see it flex and shift as the molten world beneath pushes upward. It's not one continuous sheet. Instead, it's a patchwork of irregular plates, some the size of countries, others barely large enough to host a hill. They drift on the softer, partially molten layer beneath slowly, almost lazily, but even at this early stage, they collide and separate in a way that foreshadows the tectonic drama to come. You could call them the prototypes of continents and ocean floors, though they wouldn't be recognizable to you now. These plates are born in violence. Where the crust cracks open, magma surges up, spilling out in glowing rivers that cool into jagged basalt. Elsewhere, the crust buckles and folds as it presses against itself, building the planet's first miniature mountain ranges. You imagine that if you could walk across one of these newborn highlands, you'd feel the ground trembling beneath your feet, hear the distant rumble of the molten underworld like a deep animal growl. Odd fact: the oldest rocks on Earth that we've found tiny zircon crystals are over 4.3 billion years old, nearly as ancient as the crust itself. They're smaller than grains of sand, yet they hold chemical clues about the planet's earliest surface conditions, including evidence that liquid water existed even then. Scientists still debate whether these ancient crystals formed on a calm, stable crust or amid relentless volcanic upheaval. From above, the scene is both alien and familiar. You see the dark ocean basins deepening, framed by bright, fresh crust where magma has cooled. In the shallows, islands of rock jut out, surrounded by curling waves. These rocky patches will someday become anchor points for life, but right now they're barren, baked by the sun by day and chilled by the long, wind-torn nights. The air is thick and heavy, still rich in carbon dioxide, methane, and sulfur compounds. Breathing here would feel like inhaling through a hot, wet cloth, the air clinging to your lungs. But the atmosphere is working its quiet magic, trapping heat and keeping the surface warm enough for the oceans to remain liquid. Without it, Earth might have frozen into an icy wasteland long before life had a chance to begin. Down at the edges of the crust, you can see geothermal activity bubbling away. Underwater volcanoes release plumes of minerals into the young seas, turning the water milky with chemical richness. These are not just geological curiosities, they're future laboratories for life's experiments. Every mineral particle, every shift in temperature, is a potential ingredient in the recipe that will eventually produce cells, DNA, and the absurd reality of cats in cardboard boxes. And here's the quiet miracle. Despite all the upheaval, the crust holds. It will crack and reform 1,000 times, yes, but from now on the Earth will always have a surface to stand on. A stage has been built, uneven, ever-changing, but sturdy enough for whatever story comes next. As you drift along the horizon, you catch sight of a volcanic arc glowing red in the dim light. Magma fountains leap into the air, cooling mid-flight into shards that rain down into the ocean. Steam rises in twisting columns, lit from beneath by the molten glow, giving the scene an otherworldly beauty. It's violent, yes, but also oddly serene, like watching a campfire from far enough away that the sparks can't reach you. Somewhere deep inside the crust, heat continues to rise from the still cooling core, driving convection in the mantle. This constant motion will one day create supercontinents and tear them apart again over and over for billions of years. Right now, you're watching the very first rehearsal of that endless tectonic play. You let the image settle in your mind, a patchwork Earth, stitched together from volcanic rock and ancient crystal, floating on a restless interior. The oceans lap at its edges, the atmosphere hugs it tight, and somewhere in all this raw energy, the conditions for something extraordinary are quietly assembling. The crust may be young and fragile, but it's enough a first draft of the world's surface, waiting for the rest of the story to be written. You float a little higher from the newborn crust, listening to the planet cool and sigh, when the sky suddenly remembers an old bruise. Out past the haze, a wanderer the size of Mars, call it Theia, if you like. Formal introductions arrives late and uninvited, and the quiet world you've been watching becomes a bell struck hard. Rock meets rock in a flash of world-forging violence, and for a few staggering hours, Earth forgets its shape. Stone becomes spray, spray becomes a ring, and the ring glowing, molten, and shimmering like a necklace of fresh lightning gathers itself into one companion, the moon. You don't hear a bang so much as a deep, cathedral-sized gong that seems to keep ringing in your bones. Not every scientist agrees on the exact choreography. Some argue it was one clean strike. Others propose a messy sequence of impacts, or even a vaporized synestia, a donut of rock, vapor that cooled into two worlds. Scientists still debate whether a single giant collision did the job, or whether multiple blows and melt vapors wrote the script. Either way, the curtain rises on a duet, Earth and Moon, forever tied by gravity's invisible ribbon. You watch the newborn moon glow with leftover heat, so bright it casts silver fire on the ocean still steaming below. Its face is closer than you're used to, alarmingly close, so close that tides are titans. Picture waves tall, as office towers marching across the proto-coastlines twice a day, grinding rock to meal, stirring chemistry like an obsessive chef who refuses to stop whisking the primordial broth. Those tides matter. They create endless littoral laboratories, wet, dry, where molecules try combinations the way Insomniacs try podcasts, until at last something living can hold a tune. Odd fact to tuck under your pillow, the moon is slipping away from us right now at about 3.8 centimeters per year, the world's slowest breakup. At that pace, it's the kind of relationship drift you only notice when the vacation photos don't quite line up on the shelf anymore. Another quiet fact. Fossils of ancient corals and tidal rhythmites hint that hundreds of millions of years ago, a year held approximately 400 days, because days themselves were shorter. The moon has been our cosmic brake, hand on the shoulder of Earth's spin, whispering, "Easy, you don't have to sprint." You feel that braking is a mood more than a motion. The planet, freshly corset and crust-skinned, begins to lengthen its days from a frantic 5 hours towards something almost humane. A slower spin means gentler winds, kinder seasons, and eventually nap-time sunsets that last long enough for tea to cool. Like many good things, we owe that serenity to gravity and patience rather than any central planning committee. If there had been a committee, they would still be arguing about the agenda. The moon does another subtle kindness. It steadies Earth's tilt. Without that stabilizing tug, our axis might lurch like a shopping cart with a rebellious wheel, flipping climates with the fickleness of a streaming algorithm. With the moon, the tilt wobbles, yes, but within a comfortable cradle. Seasons become reliable poetry instead of chaotic plot twists, summer, autumn, winter, spring, each verse rhyming with the last. You can feel the future relief of farmers, migratory birds, and anyone who has ever booked a picnic. You drift through the high dark, and notice how this new companion turns its face slowly, always keeping one cheek toward Earth. Tidal locking, another gift of time, means we will learn one lunar face like a friend's, while the far side stays private and mysterious, the shy sibling who skips the party. There's tenderness in that arrangement, a a quiet choreography that will teach humans to count months, tell time, and make myths. Werewolves, poets, sailors, the guest list is eclectic, the dress code silver. Look down at the coastlines being born. Twice a day, the shorelines inhale and exhale, pulling water into rocky hollows where warmth and minerals work on the alphabet of life. In some tide pool, much later, a child will skip a stone and giggle. Tonight, you watch a planet skip itself into rhythm. Jokes feel safe here, even small ones. Yes, Earth basically got smacked so hard it made jewelry. Yes, our day-night cycle has a personal trainer named Luna, who specializes in low-impact cardio. No, you do not need to tip though. You might light a candle next time you see the full moon and whisper, "Thanks." The moon's early face wears scars, enormous basalt plains you will one day call Maria, seas that are not seas, poured from ancient eruptions when the moon's own heart finished cooling. You imagine the view from an early shoreline, a disk looming huge, mottled and radiant, cycling from crescent to gibbous like a lantern with a thoughtful dimmer switch. Every change in phase becomes a lesson plan, waxing hopes, waning memories, the comfort of repetition. Later, you'll write poems about this. Right now, you simply breathe with it. Science fact to carry forward. Those giant tides didn't just stir chemistry, they bled rotational energy from Earth and transferred angular momentum to the moon's orbit, pushing it outward. The math is quiet, but relentless, like a savings account you never check that somehow grows every year. You don't need equations to feel it. You can sense the calm expanding, the day lengthening grain by grain. But nothing is perfect, not even in a bedtime story. The same tides that nurture shorelines can flood them. The same stabilizing tilt can still wobble to drought or ice if nudged by volcanoes, currents, or the occasional grumpy asteroid. Beauty is negotiated, not guaranteed, and yet standing in cosmic scale, you see how profoundly the moon's gentle governance made room for gentler futures. Coral reefs will ride these tides, mangroves will sip them, children will learn the word crescent and feel clever. Third light joke, the moon is also the original nightlight. Zero batteries, full ambiance. You glance back at the ring of debris that did not become the moon's swept, fallen, melted into Earth again. Even the leftovers had work to do, delivering trace elements, deepening basins, reminding you that design here is a conversation between accident and endurance. If you wanted a moral, you could say, being shaped is often a contact sport, but in time, the bruises memorize the dance. One last look at the paired orbits. Earth turning, moon circling, tides breathing, tilt steadying. The duet has found its tempo. Below, the crust thickens at the margins. Above, the atmosphere begins to calm. You can almost hear shorelines whispering to chemistry. When you're ready, come ashore. And you, comfortable now in the glow of a faithful satellite, let your shoulders loosen. The worst of the chaos has learned to count. From up here, the air is finally beginning to behave like a character, instead of a background less a smothering cloak, more a complicated friend who is learning how to breathe at a steady pace. Below you, the tides the moon has taught to count keep stroking the shorelines. Above you, sunlight sifts through a sky that still can't decide what color it wants to be. The first atmosphere is not the blue comforter you know. It's thick, steamy, metallic at the tongue, a mix of volcanic whispers and cosmic leftovers, water vapor billowing from vents, carbon dioxide swirling in wide bands, nitrogen settling in for the long haul, with pinches of methane, ammonia, hydrogen sulfide scents that would clear a room faster than a forgotten lunch in the office fridge. You can hear it, if you listen, the planet exhaling. Every volcano is a lung, every fissure is a sigh. Hot columns of gas rise and condense, the high air bruised by lightning that stitches clouds together with bright, quick thread. The recipe is simple and relentless, outgassing from a still warm interior plus sunlight plus time equals weather. You watch steam climb, gather into towering anvils, and fall as rain that hisses, runs, and returns to the sky. The water cycle is rehearsing its lines until they sound natural. Not all the early air sticks around. The lightest gases, especially hydrogen, slip away towards space, peeled off by the sun's ultraviolet insistence, and the magnetic field, still growing stronger, tries its best to keep the solar wind from stealing too much. Nitrogen proves stubborn and stays, content to be the quiet majority. Light joke 1. Nitrogen is the introvert of gases everywhere, dependable, and somehow still overlooked in group photos. Over millions of years, the atmosphere thickens into a greenhouse that holds in heat, and this is crucial because the young sun is fainter than the one you know. By rights, the oceans should freeze, but the blanket of CO2 and methane keeps the planet liquid, a gentle solution to the famous faint young sun paradox. Scientists still debate whether the earliest air was strongly reducing, rich in hydrogen and methane, or more neutral, dominated by nitrogen and carbon dioxide with only a flirt of methane. The difference matters because chemistry follows the menu. What the sky serves, the seas will try to cook. In some eras, the atmosphere may have worn a photochemical haze, a coppery veil like Titan's, spun from methane under ultraviolet light. Under such a canopy, sunsets would melt into syrup, and the planet would look like it had been dipped in tea. You can almost taste the astringency on the back of your tongue. Odd fact to pocket for later. Raindrop imprints fossilized in ancient volcanic ash have been used to infer past air density. Imagine that reading the weight of the sky from the dimples of vanished storms, like guessing the thickness of a quilt from the pattern it leaves on your cheek. Another delight. A single breath you take tonight will contain something like 25 sextillion molecules. Statistics practically guarantee you'll inhale a few that once swirled in these early mists, which is both poetic and, if you think too hard about it, a little intimate. Down at sea level, the smell of sulfur and wet stone would be overwhelming, the air short on oxygen to the point of fantasy asphyxiation. Life, when it begins to test the waters, won't be craving oxygen at all. To the first microbes, oxygen is a corrosive menace. They'll choose environments where ions, sulfides, and simple carbon compounds provide energy in cozy, oxygen-free darkness. You peer into a black smoker chimney, minerals blooming like stone flowers where superheated water meets cold sea, and you feel that tinkling thrill. Chemistry is getting ambitious. The sky keeps experimenting. As continents stub into existence and weather grinds, rock to powders, rivers deliver minerals to the oceans, and cycles tighten. Carbon dioxide dissolves into seawater, reacts with rocks, settles into sediments. Volcanoes belch it back out a planet-sized inhale and exhale tied to plate tectonics. Some days, geologically speaking, methane builds up and the planet warms. Other days, continents cluster at latitudes that invite ice, and sunlight bounces away, cooling the world. Climate is a seesaw balanced on slow, grinding fulcrums. You learn to enjoy the rhythm without demanding a metronome, a science factor set gently on your nightstand. Around 2.4 billion years ago, billions of gentle heartbeats from where you're hovering, the great oxidation event will arrive. Tiny, tireless cyanobacteria will perfect photosynthesis that splits water, releasing oxygen as a waste product. At first, that oxygen vanishes into the oceans, binding with dissolved iron to paint the seafloor in banded iron formations, rust-striped ledgers of planetary change. Only when the sinks fill will oxygen leak into the air in earnest, turning the sky truly, deeply blue and setting the stage for ozone high above to form a UV shield. You can almost feel future sunlight soften on your skin. Before that turning, the atmosphere performs small miracles. Lightning breaks molecules, ultraviolet forges and fractures others. Meteors add exotic trace elements. Volcanoes swap gases between rock and sky. It's messy R&D. The smell after lightning ozone, sharp and clean, is the barest foreshadow of a future where O2 will make campfires bright and morning jogs plausible. Right now, oxygen is barely a rumor. Light joke 2. Imagine trying to sell oxygen to early microbes. Crisp, invigorating, and getting a 1-star review. Burns my proteins. Would not recommend. You look sideways at the color of the sky. It wants to be blue, because tiny molecules scatter short wavelengths, the Rayleigh trick, but haze keeps muting it. As methane waxes and wanes, the palette slides from metal grey to tea brown to smoky cobalt. On some afternoons, the sun would glow copper and the horizons bruise purple, and you feel a little envious of any eyes that might someday have watched those colours soberly, knowing what they meant. Beauty is not a luxury here, it's a readout, a graph painted in air. The first atmosphere is also a therapist for temperature swings. Without it, days would scorch and nights would snap freeze. With it, the pendulum slows. Winds shoulder the load of redistributing heat, spinning storms that scrub the surface, transfer salts, and draw invisible lines of latitude and habit. Bit by bit, the ceiling of the world rises from choking to breathable, from poisonous to perfumed, though perfumed will always be relative when plankton are involved. Light joke 3. Someday algae will turn half the planet into a smoothie bar, and you'll pretend you like it. There's a tenderness in the way risk becomes refuge. Greenhouse gases save the oceans from ice. Later, too much of the same warm blanket threatens to overheat the bed. Photochemical hazes shield the surface from ultraviolet. Too much haze starves the surface of light. The planet learns to tune itself with levers that have no labels. You think about your own breathing, the way a slow inhale can steady the brain, and you feel the kinship. Atmosphere as biofeedback, planet as a body practicing calm. Scientists still debate whether certain tipping points, like the rise of oxygen, were driven more by biology, tectonics, or the availability of trace metals like nickel that set microbial metabolisms. Was oxygenation an inevitable march, or a lucky stumble amplified by continents cracking just so? The arguments are cordial, the equations fierce, and the rocks patient. You're allowed to rest inside the not knowing. Uncertainty here is not a hole but a porch to sit on. Late in the day, the long, geologic kind, the sky, clears a little more, and the light comes through honest. You can finally imagine a breeze that smells of wet stone and something green that hasn't quite been invented. When ozone thickens in the stratosphere, the world below will relax under gentler UV. Shorelines will host braver chemistry. Cells will try membranes that don't crisp on contact with sunlight. The atmosphere, once a hazard, becomes a guardian. You float there, feeling the planet's pulse in pressure and wind. The air is still not for you, but it is working toward someone, toward voices and flutes, and the rise of a chest in sleep. You let that thought settle like silt, and the sky, negotiating between haze and blue, looks back at you with the shy confidence of a beginner who is, against all odds, getting good at this. The oceans glisten under a sky still shy of blue, and you can feel the planet holding its breath for something unprecedented. For billions of years after the crust hardened and the first atmosphere took its seat, Earth has been busy setting the table: water, minerals, cycles, and heat. But now comes the first guest. Somewhere in the shallows of a warm lagoon, or perhaps deep in the mineral-rich darkness of a hydrothermal vent, chemistry begins to flirt with biology. It doesn't look like much. You wouldn't mistake it for life if you passed it on the street, mostly because it doesn't walk, wave, or ask you to sign a petition. It's just molecules, bumping into each other like awkward partygoers, forming chains, breaking apart, reforming again. But in those bumps, patterns start to emerge, molecules that can make copies of themselves. Clumsy at first, but each generation a little better. Some scientists picture a primordial soup of amino acids, sugars, and lipids stirred by tides and warmed by sunlight. Others favor the deep-sea vent scenario, where energy from the Earth's interior drives reactions in sheltered, mineral-lined chambers. The debate remains unresolved, and maybe that's part of the charm. Life's origin story is as elusive as the first blush of a sunrise. Odd fact: modern experiments have shown that amino acids, the building blocks of proteins, can form under conditions mimicking early Earth seas, even without biology to guide them. Another twist: meteorites have been found carrying amino acids, suggesting that some of the ingredients for life might have been delivered pre-packaged from space, like care packages from a very distant neighbor. The first true cells, prokaryotes, will be humble things, no larger than a grain of dust, but packed with ambition. They will live in a world without oxygen, relying instead on chemical energy from iron, sulfur, or methane. To them, oxygen is a corrosive toxin, the microbial equivalent of bleach fumes. But this early hostility toward oxygen won't last forever. In time, some of their descendants will figure out how to turn sunlight into food, releasing oxygen as waste, reshaping the planet's chemistry in what will be remembered as the Great Oxidation Event. Right now, though, life is fragile, tentative, hiding in the safest corners of the planet. In hydrothermal vents, black smokers release water heated to over 350 degrees Celsius, loaded with dissolved minerals. Here, microbial mats cling to chimney-like structures, thriving in chemical gradients that would kill anything you currently call dinner. In tidal pools, fatty acid molecules spontaneously form spheres, protocells that trap other molecules inside, a primitive echo of the membranes that will one day protect complex cells. It's strange to think how much of what you are, bones, breath, laughter, rests on these tiny, unseen beginnings. The warmth of your morning coffee, the sigh you make when you see a sunset, the impulse to hum when you're content, all of it is built on a chemistry that, here and now, is just learning how to self-organize. If you could touch one of these early cells, you'd find nothing to impress the eye. But if you could watch their lineage, you'd see every tree, whale, and human spill forward from this moment, like water from a hidden spring. Light joke 1. If early cells had dating profiles, they'd list likes, heat, sulfur, long division, dislikes, oxygen, cold fronts, meteor impacts. Not much swiping would be needed, they're pretty much the only singles in town. Scientists still debate whether life started once and spread everywhere, or whether multiple origins flickered into existence, with only one winning the long survival game. If the latter is true, Earth may have hosted entire branches of life that simply vanished, leaving no fossils, no trace, just a silence between the molecules. The early biosphere is not yet visible from space, but it's already altering the planet. Microbes cycle carbon, nitrogen, and sulfur, changing the chemistry of oceans and atmosphere. Some live in mats that trap sediment, forming stromatolites, layered rock structures that will persist for billions of years as a geological diary of life's first steps. You imagine a shallow bay, quiet except for the lapping of waves, dotted with these knobby formations. They look like nothing special, but they are as revolutionary as the invention of writing marks left by living authors in the stone. Odd fact number 2. The oldest confirmed stromatolites are about 3.5 billion years old, older than most of the continents they stand on. Imagine living in a house older than the neighborhood, older than the road, older than the concept of houses. The pace here is glacial, not in the cold sense, but in the patient sense. Millions of years pass between small improvements. Molecules learn to copy themselves more efficiently. Membranes become less leaky. Energy harvesting becomes more versatile. Every success is stored not in memory, but in structure, passed forward in the architecture of molecules. Life is not yet in a rush. It doesn't have deadlines, predators, or taxes. It only has opportunity space to spread, resources to exploit, time to refine its recipes. You float above the planet, watching the surface shimmer in the light, knowing that somewhere down there, the script for the rest of history is being written in a language no human can speak, but every human will inherit. Light joke 2. If evolution had a progress bar, it would be stuck at 3% for the next billion years, with a tiny note underneath reading, installing mitochondria. This may take a while. And here's the quiet wonder. These first living systems are not just passengers on Earth's journey. They are engineers, reshaping their own environment. By altering the chemistry of the oceans, they change the gases in the air. By fixing nitrogen, they enrich the soil that doesn't exist yet. By dying, they provide nutrients for others. Even now, life is in dialogue with the planet, and the planet is listening. You hover a moment longer, imagining the slow multiplication happening beneath the waves. Each cell divides, and divides again and again, an invisible tide that will one day flood the world with green, with predators, with minds capable of telling this story back to itself. The ocean's surface glints as the sun sets, and somewhere in the deep, chemistry turns over in its sleep, dreaming of eyes. The oceans are vast and restless, but for more than 1 billion years, they are ruled by creatures so small you could line 1,000 of them across the width of a grain of sand. The reign of the microbe is not flashy. There are no teeth, no shells, no speeding fins slicing through the currents. Just endless drifting cells, each one a miniature factory, pulling in molecules, spitting out waste, and quietly altering the chemistry of the entire planet. You hover over an ancient shoreline and look down at a shallow bay, its surface broken by knobby, lumpy structures, stromatolites again, but now more abundant, their layered mats busy with cyanobacteria. These tiny architects are performing a trick that will one day become as commonplace as morning toast: photosynthesis. Using sunlight, water, and carbon dioxide, they create sugar for themselves and release oxygen as a byproduct. At first, that oxygen doesn't accumulate in the air. It's gobbled up by dissolved iron in the oceans, rusting it into reddish-brown minerals that drift down to coat the seafloor. Layer after layer, the planet is painting itself in iron stripes. Odd fact, these banded iron formations are some of the most striking geological records on Earth, revealing not just chemistry but the exact moments when oxygen production briefly outpaced consumption. Imagine a painter whose canvas is the ocean floor and whose brushstrokes are counted in millions of years. For much of this era, oxygen is still rare in the atmosphere. To most microbes, it's a poison. Some huddle in oxygen-free pockets, living off sulfur or methane, while others evolve defenses, tolerating small amounts of the reactive gas. But oxygen is persistent. As the sinks iron, volcanic gases become saturated. More and more of it escapes into the air. Eventually, the great oxidation event changes everything. The sky shifts toward blue, and high above, a layer of ozone forms, shielding the surface from the sun's harshest ultraviolet light. Scientists still debate whether the rise of oxygen was sudden or slow, and whether it was triggered by evolutionary innovation, changes in tectonic activity, or even shifts in Earth's orbit that altered climate and nutrient cycles. But whatever the cause, the consequences are immense. Life must adapt or vanish. Many anaerobic species retreat to deep sediments or oxygen-poor environments, while others evolve to use oxygen in respiration, a far more efficient way to extract energy from food. It's an ecological coup, and aerobic life will ride that advantage all the way to complex multicellular forms. From space, you wouldn't notice these microscopic dramas. You'd only see the oceans darkening with pigment as different kinds of plankton evolve, coloring the water in shades of green and red. Blooms come and go with the seasons, each one a quiet engine driving the carbon cycle, pulling CO2 from the air, locking it away in shells and sediments, and influencing climate in ways no one could guess from the surface. Down in the depths, microbial mats thrive around hydrothermal vents, still feeding on chemical energy from Earth's interior. Some use sulfur instead of sunlight, their metabolism built for darkness. Others swap genetic material with astonishing ease, blurring the line between species. In this microscopic world, evolution is not a slow trickle, it's a rapid, swirling exchange of solutions, as if every invention is instantly shared across the network. Light joke 1. If microbes had social media, their sharing culture would make the internet look stingy. You'd post a cute photo of your lunch, and within seconds, someone in another ocean would not only copy it, but improve it for sulfur-rich environments. The sheer longevity of the microbial era is humbling. For over 2 billion years, nothing larger than a single cell dominates the biosphere. No forests, no fish, no flowers, just bacteria and archaea, and later, the first eukaryotes. Eukaryotes are the game changers. Cells with internal compartments, including a nucleus to store DNA, and crucially, mitochondria to supercharge energy production. Mitochondria are themselves the descendants of once free-living bacteria, enslaved or adopted, depending on your PR department, by a larger host cell in a rare act of biological merger. Odd fact number 2. Every mitochondrion in your body has its own DNA. separate from the DNA in your cell nucleus, a faint memory of its bacterial past. You are, in a literal sense, a chimera. From the outside, the microbial world appears static, but it is in constant flux. Mutations arise, new metabolic tricks spread, old lineages vanish. Some microbes learn to survive in extreme heat, others in near-freezing brine. A few develop the ability to fix nitrogen from the air, converting it into a form usable by other organisms, a service so vital that without it, the chain of life would collapse. You notice the planet itself responding. As microbes pull carbon from the air and lock it into rock, the greenhouse effect weakens, and ice creeps toward the equator in great global glaciations, snowball Earth events that will later challenge life's resilience. Microbes survive these freezes by clinging to pockets of liquid water beneath the ice, waiting out the cold for millions of years. Light joke 2. If microbes had mottos, one might be, stay small, stay hidden, stay alive. Another might be, when the world freezes over, take a very, very long nap. Through it all, the invisible rain continues. You breathe in today and inhale their descendants. You eat and depend on their metabolic handiwork. Your own cells host their ancient relatives. They are not just Earth's first rulers, they are still here, still calling the shots in ways you barely notice. From your vantage point above the planet, the oceans shimmer in the sunlight, their colors shifting with plankton blooms. You know the surface beauty hides an ancient truth. This is their world, and we are only visitors with elaborate hobbies. Somewhere below, a single cell divides, the same way its ancestors have done for billions of years, and the rhythm is so steady, so patient. You almost miss the fact that this is the heartbeat of the planet. For eons, the seas have been ruled by single cells, quiet, steady, efficient, but now something changes. It's not a sudden leap so much as a long exhale after holding a note for billions of years. Cells begin to cooperate, to specialize, to form bodies that are more than the sum of their parts. And then, as if the curtain lifts on a stage that's been under construction forever, the Cambrian seas burst into a chaos of color and movement. If you could hover over one of these early oceans, you'd see creatures so strange that even science fiction illustrators might hesitate to draw them. Trilobites the size of dinner plates scuttle across the seafloor, their segmented shells glinting like bronze armor. Spiny worms wave fronds from burrows, filtering plankton from the water. Above them, sleek predators Anomalocaris, with eyes the size of cherries and a mouth like a pineapple ring turned inside out, glide in search of prey. It is the planet's first true arms race, and everyone seems to have gotten the memo at the same time. Odd fact, the Cambrian explosion, which began around 541 million years ago, saw the appearance of most of the major animal groups we know today. In evolutionary terms, it's like an overnight festival where almost every band that will ever exist shows up to play a set. The reasons are still debated. Oxygen levels rising high enough to support larger, more active bodies, genetic innovations like the Hox genes that control body plans, and ecological pressures that reward speed, armor, and new ways of feeding. Scientists still argue about which of these was the spark, or whether it was the unlikely combination of all of them that lit the fire. From your vantage point, you can see that the seafloor is no longer a static carpet of microbial mats. It's riddled with burrows, trails, and feeding marks. The water column above is crowded with plankton, swimming larvae, and the first jellyfish-like drifters. Organisms are experimenting with eyes, with limbs, with hard shells, things that can see, move, and defend themselves. Predation changes everything. Now there's reason to move quickly, to hide, to evolve better armor, or more cunning ways to attack. Light joke 1. If you think office politics are cutthroat, imagine being a soft-bodied worm in the Cambrian. One wrong wiggle and your lunch. Some creatures adopt brute force, others rely on stealth. Sponges filter the water quietly, while early arthropods develop jointed legs and compound eyes. Even the plants, or more accurately, the algae, are part of the arms race, evolving shapes and chemical defenses to avoid being eaten. Odd fact number 2. Some Cambrian animals had compound eyes with more lenses than those of modern insects, giving them vision sharp enough to track fast-moving prey in dim light. For animals living in shallow, often murky seas, this was like discovering high-definition television before anyone else even knew how to make a candle. The Cambrian seas are not peaceful, but they are rich beyond anything the planet has seen before. Every niche, every little environmental opportunity is being explored. Some creatures dig into the sediment, others cling to rocks, some drift passively, while others dart and chase. Food chains form and lengthen. Energy moves faster through the system, supporting more complex and active life. And yet, even in this burst of innovation, extinction lurks. Not every experiment succeeds. For every body plan that will persist into the modern era, there are dozens, hundreds that will vanish, leaving only fossils in the stone. You can imagine walking through a Cambrian fossil bed, holding a rock that contains the imprint of an animal with no living relatives, no descendants, a completely separate branch of life's tree sawed off by time. Light joke 2. The Cambrian might have been the first and last time in history that everyone was new here. There was no old guard, no tradition, just the evolutionary equivalent of freshmen trying to find the cafeteria. From above, the oceans shimmer with the movement of these new players. You see Anomalocaris darting after trilobites, trilobites scuttling over sponges, and sponges filtering the endless rain of plankton. The diversity is staggering, like the sudden jump from a single flute to a full orchestra, each playing its own part in a complex score. Scientists still debate whether the Cambrian explosion was truly sudden, or whether earlier life forms simply left fewer fossils. Soft-bodied creatures, after all, don't preserve well, and the rock record is a fickle archivist. But whether it was a slow build or a genuine burst, the impact is the same. The stage of life has expanded, and the actors are no longer confined to the microscopic. You can almost feel the energy in the water, the constant flicker of movement, the endless testing of strategies. You watch as a trilobite burrows under the sand to escape a predator, only for that predator to develop better senses in the next generation. The evolutionary feedback loop has begun, and it will never stop. Light joke 3. If natural selection were a sport, the Cambrian would be the first professional league with no referees and very loose rules about biting. The sun sets over the Cambrian seas, turning the water into liquid bronze. The strange shapes beneath the surface move on, feeding, hiding, chasing. You drift higher, knowing that what you've just seen is only the beginning, that this explosion of life will ripple forward for hundreds of millions of years, shaping everything that follows. Somewhere, in that shimmering depth, a tiny ancestor of yours swims, unaware that one day, one of its descendants will be telling this story back to the stars. The Cambrian seas eventually calm, not in the sense that life slows down, but in the sense that the chaos finds its rhythm. Predators and prey refine their dances, algae thicken into mats along shorelines, and the seafloor becomes a labyrinth of burrows and anchor points. But somewhere, in quiet shallows that catch the sunlight just right, an entirely new conquest begins. Green creeps out of the water and takes its first hesitant steps onto land. At first, it's not the lush, rolling carpets of grass you know. The pioneers are small, tough, and not especially glamorous ancient relatives of mosses, liverworts, and hornworts. Without roots, they cling low to damp ground, drinking straight from thin films of water. They can't wander far from their soggy cradle. Without the buoyancy of the sea, they must fight gravity for the first time, but they have sunlight unfiltered, abundant, and free of competition. Odd fact, before plants arrived, land surfaces were bare rock, sand, and perhaps thin bacterial crusts. The colors of Earth's continents would have been a stark mix of grey, brown, and rust red. The arrival of green transformed the visual palette of the planet. These early plants don't have flowers, seeds, or even proper leaves. Instead, they rely on spores, tiny dust-like packets that drift with the wind or wash into new puddles. When the conditions are right, they grow into small mats that trap moisture and begin to break down rock into soil. This is the beginning of the Green Revolution, slow, quiet, and yet utterly transformative. Scientists still debate exactly when this colonization began. Fossil spores suggest around 470 million years ago, but the effect is clear. By drawing carbon dioxide from the air and locking it into organic matter, plants begin to influence climate. More greenery means more carbon pulled from the atmosphere, which can cool the planet. Over millions of years, this helps set the stage for glaciations, ice creeping further toward the equator than it has in ages. Alongside plants, fungi emerge as crucial partners. Their underground filaments weave into plant tissues, helping them absorb minerals from stubborn rock. This symbiosis is so successful that nearly every modern plant still relies on it. Light joke 1. The first big land-based partnership wasn't humans and dogs, it was plants and fungi, and they've been quietly running the world ever since. Odd fact number 2. Lichens partnerships between fungi and photosynthetic algae or cyanobacteria were among the first to really thrive on bare rock. They secrete acids that break minerals apart, helping create the earliest soils. Think of them as the original landscapers, working slowly but for free. The greening of land triggers a chain reaction. Insects' ancient ancestors, wingless, soft-bodied crawlers, begin to explore the new buffet of plant life. Some nibble on spores, others scavenge decaying material. Over time, their descendants will develop mouthparts, specialized for biting, chewing, and sipping. But here in the early days, the menu is still limited and experimental. Light joke 2. You could say these early plant eaters invented leafy greens before it was trendy, and they didn't even need salad dressing. With plants on land, the oxygen they produce no longer just bubbles into the sea, it floods into the atmosphere. Over millions of years, oxygen levels rise enough to support larger, more active land-dwelling creatures. The stage is being set for the eventual arrival of amphibians, reptiles, birds and mammals. But for now, the continents belong to mossy mats, low-slung fungi, and the occasional adventurous arthropod. From above, you can see the transformation. What were once bare, weathered shorelines now shimmer with a faint green haze. The air over these patches smells sharper, cleaner, though that's your poetic sense talking. In reality, the scent is a mix of plant compounds and earthy decay. Rain falls, and the new vegetation slows its path back to the ocean, trapping water in soils and altering erosion patterns. Rivers run differently, their banks held in place by the first primitive root-like structures. Scientists still debate whether the earliest land plants caused one of Earth's great mass extinctions in the oceans. By drawing down carbon dioxide and cooling the planet, they may have triggered glaciations that disrupted marine ecosystems. If true, it's a reminder that even the quietest revolutions can have unintended consequences. Light joke 3. Plants may seem peaceful, but they've been changing the climate since before humans were tall enough to see over the grass. You hover higher, taking in the planet's new colors. Blue seas now meet not just grey and brown continents, but green coasts creeping inward. It's subtle from here, but you know it's only the beginning. Over time, plants will grow taller, develop vascular systems to carry water, and eventually evolve seeds to colonize drier interiors. Forests will rise, insects will flourish, and the world will fill with the rustle of wind in leaves. For now, though, the Green Revolution is still a whisper. You can almost hear it in the breeze, a soft exhalation from a moss-covered rock, a gentle promise that this once barren land will not stay empty. The same sunlight that shimmered over the Cambrian seas now falls on leaves, and for the first time, the continents themselves begin to breathe. The green tide on land spreads, and with it, the continents start to look less like barren stone and more like living canvases. Taller plants evolve club mosses, horsetails, and the first true ferns sending stems upward to catch more sunlight. Leaves appear, wide and flat, their surfaces drinking in light with a hunger the early mosses could never match. With roots and vascular systems now in place, plants can pull water from deeper in the soil, freeing them from the constant need to cling to damp shorelines. Forests begin to form, not the towering oak and pine forests you know, but dense, spore-filled jungles where every inch is draped in green. From above, these ancient forests look almost alien. The air is thick with moisture and spores, giving everything a faint golden haze when the sun cuts through. The tallest trees stretch nearly 30 meters, their trunks sheathed in bark and their crowns forming a canopy that blocks much of the light from reaching the ground. In the shade below, a tangle of smaller plants competes for what little sunlight filters down. The atmosphere here is rich in oxygen, richer, in fact, than at almost any other point in Earth's history. Odd fact, during the Carboniferous period, oxygen levels may have reached 35%, compared to today's 21%. This abundance of oxygen allowed some insects to grow to truly unsettling sizes. Dragonflies with wingspans of 70 centimeters, millipedes over 2 meters long. Imagine hiking through a forest where the hum of dragonfly wings sounds like small helicopters passing overhead. The forests change everything. Roots break apart rock, speeding the formation of soil. Plant debris piles up in thick layers, trapping carbon that would otherwise return to the air. Over millions of years, these layers will be buried and compressed, becoming coal, the stored sunlight of ancient forests, waiting far in the future to be dug up and burned by a species that doesn't exist yet. Scientists still debate exactly how these high oxygen levels affected climate and life. Some suggest that the atmosphere became more flammable, making wildfires more common and intense. Others note that the high oxygen content might have boosted the metabolism of early animals, allowing for greater activity and growth. Either way, the forests are both a gift and a risk, reshaping ecosystems in ways that will ripple forward through time. The animal world is quick to respond. Amphibians, which had been confined to moist environments, now spread further inland, following the green corridors of rivers and swamps. Insects diversify explosively. Cockroaches, crickets, and early mayflies flit between the trunks, while centipedes and scorpions prowl the forest floor. Life is no longer limited to the coasts. The interior of the continents hums and rustles with movement. Light joke 1. If you think modern camping has its hazards, imagine pitching a tent here and waking up to find a centipede longer than your sleeping bag taking a casual stroll past. Odd fact number 2. The forests also helped stabilize Earth's climate by drawing down vast amounts of carbon dioxide. This may have cooled the planet enough to trigger the late Paleozoic Ice Age proof that plants can have global influence without ever leaving their roots. These early forests are unlike anything you've seen. No flowers, yet those are still hundreds of millions of years away. No fruit to sweeten the air, no bird calls to fill the canopy. But there's a sense of permanence here. For the first time, the land is more than a place to pass through on the way to somewhere else. It's a destination, a habitat, a home. You hover above a swampy lowland, watching giant horsetails sway in the breeze. The water is dark, tannin-stained from fallen leaves, and you catch glimpses of sleek shapes sliding just below the surface. Early amphibians, eyes breaking the waterline like tiny periscopes. Dragonflies dart in zigzag paths overhead, chasing smaller insects through beams of green-filtered light. The smell is thick, damp earth, decay, and the resinous scent of plants baking under a humid sun. Light joke 2. You almost expect a dinosaur to step out from behind a tree, but they won't show up for another 100 million years, still stuck in traffic on the evolutionary highway. From this height, you can see how the forests knit the continents together. Rivers carry nutrients inland, animals spread spores and seeds, and weather patterns shift to accommodate the new landscapes. In some regions, plant cover cools the air and increases rainfall. In others, dense vegetation alters wind patterns. The biosphere and atmosphere are now locked in a feedback loop, each shaping the other. Scientists still debate whether the spread of forests was gradual or came in sudden bursts, triggered by evolutionary leaps in plant design. What is clear is that once the forests established themselves, they became one of Earth's most powerful engines of change. The soil they built, the carbon they stored, the oxygen they released, all of it would define the path for life to come. Light joke 3. Forests may not walk or talk, but they've been quietly running the planet's climate system for hundreds of millions of years. The rest of us are just late arrivals to the meeting. The sun dips low, and shadows stretch across the canopy. In the dimming light, fireflies, ancient relatives of those you know, begin to flash their pale signals. You hover above, the hum of insect wings rising like a gentle chorus. Below, the forest exhales into the cooling air, releasing scents that will linger through the night. You know that in the deep time ahead, these forests will change, vanish, and reappear in new forms, but tonight they are the green heart of the world, beating strong. For a while, the forests reign unchallenged, their trunks stretching skyward, their roots lacing through the soil, their canopies filtering sunlight into emerald twilight. But Earth, ever restless, rarely lets stability last. Somewhere in the deep future, from this forested scene, a shadow begins to gather, a slow, creeping shift that will become the greatest biological crisis the planet has yet seen. The great dying is on its way. It doesn't start with drama. At first, it's subtle. A few species vanish here, a reef fails to recover there. But beneath the surface, both literal and metaphorical, the planet's systems are edging toward collapse. Continental plates drift, reuniting scattered landmasses into the supercontinent Pangaea. This new arrangement changes ocean currents, disrupts weather patterns, and creates vast, arid interiors, far from the cooling influence of the sea. Life on land faces longer droughts, while the oceans begin to lose the steady nutrient cycles that have kept them vibrant. Odd fact, forming a supercontinent can actually make the Earth less hospitable, despite the romantic appeal of all land being connected. Large interiors get hotter and drier, while coastal diversity shrinks as shorelines vanish into the merged mass. Then comes the real blow, volcanic activity unlike anything modern Earth has seen. In what is now Siberia, colossal eruptions open vast fissures, spewing lava across millions of square kilometers. The outpouring lasts for hundreds of thousands of years, releasing unimaginable volumes of carbon dioxide and methane. The air grows heavy with greenhouse gases, trapping heat and pushing global temperatures upward. Oceans warm, acidify, and lose their oxygen, creating dead zones where nothing larger than bacteria can survive. Scientists still debate exactly what combination of factors caused the Permian-Triassic extinction 252 million years ago, but the scale is not in dispute. Around 90% of marine species and 70% of land species disappear. Coral reefs vanish entirely. Whole groups of animals, from trilobites to certain amphibians, never return. From above, the transformation is heartbreaking. Forests brown and wither, rivers shrink to trickles, and vast deserts creep outward. In the seas, coral frameworks crumble into rubble, leaving empty plains where fish once darted and invertebrates once thrived. The sky itself seems heavier, its haze tinted by volcanic aerosols, the sunsets redder, but without joy. Light joke, one dark humor edition. If Earth had Yelp reviews during this period, the oceans would get 0 stars, water too hot, oxygen not included. No. Odd fact number 2. Some evidence suggests the extinction's intensity was worsened by the release of methane from seafloor hydrates, frozen methane ice deposits destabilized by warming waters. Methane is a far more potent greenhouse gas than CO2, and its sudden release may have triggered a runaway warming effect. Life, of course, doesn't vanish entirely. Microbes, as always, endure. In the oceans, certain hardy species adapt to low oxygen conditions, thriving in environments that would suffocate most other creatures. On land, small, resilient reptiles survive where larger animals cannot. The survivors carry with them the seeds of future ecosystems, though the recovery will be painfully slow, on the order of 10 million years before biodiversity truly rebounds. From your vantage point, you can see the scale of loss, but also the stubborn persistence. In the shallow seas, a few sponge-like organisms cling to life. Along the coasts, primitive conifers hold onto narrow strips of green. The deserts that stretch across Pangaea are dotted with hardy shrubs that tolerate heat and drought. Every living thing here has been through a filter so tight that only the most adaptable, the most uncomplaining remain. Scientists still debate whether the recovery afterward was driven more by evolutionary innovation or by the slow rebalancing of climate and chemistry. Some argue that the harsh conditions pushed life to experiment more, leading to entirely new body plans. Others believe that once the environmental stress eased, life simply refilled the old ecological niches. Either way, the world that emerges will be different from the one that died. Light joke 2. If evolution had an HR department, this would be the mass layoff that forces everyone to rewrite their resumes. From above, the Earth eventually exhales. The volcanic fury quiets, weather patterns stabilize, and the oceans begin to circulate more normally again. But the scars remain both in the fossil record and in the reduced complexity of ecosystems. Recovery is measured not in decades or centuries, but in geological ages. You hover over what was once lush forest, now a dry expanse under a pale sky. It's humbling to realize that stability is never promised, not for ecosystems and not for planets. Life here is a master of reinvention, but reinvention takes time. The Great Dying is both a warning and a prelude proof that catastrophe can reset the stage, and that even in the deepest losses, the story continues. Light joke 3. If Earth were writing an autobiography, this chapter would be called That Time I Almost Quit, but the next chapter would be, Anyway, Here's How I Invented Dinosaurs. And somewhere in that thought, you find the strange comfort that endings here are rarely absolute. Beneath the dust and silence, life waits, patient as stone. For the moment, it can bloom again. The Earth has been emptied, scraped down to its most stubborn survivors, but time, as always, refuses to sit still. Slowly, painfully, the stage begins to reset. Plants reclaim bare ground, weaving green back into the cracks of a scorched landscape. In the seas, coral-like builders cautiously return, stitching together the first fragile reefs since the Great Dying. And then, in a slow-motion unveiling that will last millions of years, a new cast of giants steps into the sunlight, the dinosaurs. They don't arrive fully formed or in the grand variety you imagine from museum halls. At first, they're modest, two-legged, lightly built reptiles, each no bigger than a large dog, darting through fern-filled clearings. But they are quick, warm-blooded enough to stay active in cooler conditions, and their legs are positioned directly under their bodies, making them more efficient runners than the sprawling reptiles that came before. In a world still fragile from extinction, those advantages matter. Odd fact: the earliest known dinosaur fossils date to about 230 million years ago, during the late Triassic. They appear alongside other archosaurs relatives that will branch into crocodiles and pterosaurs. Scientists still debate whether dinosaurs first evolved in what is now South America, or whether they were already widespread and simply lucky enough to survive environmental shifts that doomed their competitors. From above, the landscapes of the Triassic are striking. Pangaea still dominates, a vast supercontinent ringed by a single global ocean called Panthalassa. The interiors are hot and dry, dotted with hardy conifers and ginkgos. Seasonal monsoons sweep the coasts, filling rivers that spill into lush floodplains, fertile strips where life clusters in green abundance before fading again into desert. In these greener belts, the small dinosaurs find their footing. Some specialize in chasing insects and small vertebrates, darting between cycads and horsetails. Others graze on ferns, cropping low vegetation with beaked mouths. The competition is fierce mammal-like reptiles called synapsids still roam, some as large as bears, while armored herbivores and early crocodilian forms prowl the waterways. But slowly, dinosaurs adapt into niches left open by the Permian survivors. Light joke 1. If this were a reality show, the Triassic would be called So You Think You Can Survive, and the dinosaurs would be the contestants who showed up quiet, then started winning every challenge. Odd fact number 2. Triassic dinosaurs were not yet the towering giants of the Jurassic. Many were lean and agile, relying on speed rather than size for survival. The truly massive sauropods, the long-necked behemoths, wouldn't evolve until later. Over millions of years, the balance shifts. Climate fluctuations and another, smaller extinction event at the end of the Triassic open even more ecological space. Dinosaurs diversify rapidly, spreading across Pangaea in a wave of evolutionary experimentation. Insects hum through the forests, feeding on the early flowering of cycads and seed ferns. Pterosaurs claim the skies, their membranous wings casting brief shadows over riverbanks. In the seas, ichthyosaurs and plesiosaurs rule, sleek as torpedoes and as deadly as their teeth allow. From your vantage point, it's easy to see why dinosaurs thrive. They are adaptable, able to move long distances in search of food and water. Their eggs are protected by hard shells, allowing them to be laid on land without drying out. Their varied diets from fish to plants to other dinosaurs mean they can exploit almost any habitat. And perhaps most importantly, their internal biology lets them stay active in cooler dawns and hot afternoons alike, a flexibility that less efficient reptiles can't match. Light joke 2. If dinosaurs had personal ads, they'd read likes. Long walks across supercontinents, diverse diets, being around for 165 million years. Dislikes, unexpected asteroids. Scientists still debate whether the early dominance of dinosaurs was inevitable or a matter of luck. Were they always destined to rule, or did a perfect storm of extinctions and environmental shifts clear the path for them? The fossil record shows bursts of rapid diversification, suggesting that when opportunity knocks, evolution doesn't just answer, it throws the door wide open and builds a whole new house. As you hover above a Triassic floodplain, the sun glints off a shallow river where a group of early sauropodomorphs, long-necked plant-eaters, wade for water plants. Nearby, a predator lurks in the reeds, its gaze locked on a smaller dinosaur crossing open ground. A sudden chase erupts, the air filled with pounding footsteps and startled calls. Dust rises, then settles, leaving only footprints to mark the drama. Light joke 3. In the Triassic, everyone leaves big footprints. Dinosaurs, crocodiles, even the insects. You'd never need a detective. You'd just follow the trail until something decided to eat you. The days here are long and hot, but they end with vivid sunsets, dust, and volcanic haze, painting the sky in purples, reds, and molten gold. In the gathering dark, the silhouettes of dinosaurs pass between trees, their calls echoing over the cooling land. You watch them disappear into shadow, knowing that they are only at the very beginning of their reign, and that for millions of years, their shapes will define the rhythms of this world. Night falls on the late Cretaceous with its usual chorus crickets that aren't crickets, frogs that aren't quite modern frogs, and the distant footfalls of giants settling into the dark. You're hovering over a warm, shallow sea, fringed by ferns and flowering shrubs, when the sky develops a new star. It arrives without a sound you can hear, only a brightness that grows indecently fast, like someone turning up a celestial dimmer until the world is all glare and no shadow. You know what it is before it hits. The dinosaurs do not. The object is about 10 kilometers across, roughly the size of a city, and it is moving so fast that the air in front of it doesn't have time to remember it's supposed to be air. The shockwave outruns sound. For a breathless instant, the rock meets the sea and shallow crust near the Yucatan, and then the earth forgets how to be gentle. Stone flows like water. Water rises like stone. Everything swaps identities in a flash, bright enough to tattoo itself into the memory of minerals. You don't hear a bang. You feel a shove that crosses oceans. A mountain of vaporized rock and seawater erupts upward, punching a hole through the stratosphere and beyond, spraying molten droplets, tektites that cool into glass as they rain back down on continents far away. Shocked quartz grains, minerals physically rewritten by pressure, spread like forensic confetti across the globe. The impact crater, you'll someday call Chicxulub, yawns more than 150 kilometers wide, a bruise you can see from space if you know where to look and squint with the patience of geology. Odd fact to hold in your pocket: a thin, worldwide layer, rich in iridium, rare in Earth's crust, but common in meteorites, marks this moment like a black ribbon in stone. It's the planet's most somber bookmark. Turn the page, and the cast list changes. The first minutes are madness. An air blast scythes forests flat out to shocking distances. Within hours, tsunamis the height of city blocks radiate from the Gulf, racing up ancient river valleys, erasing shorelines, shouldering trees aside like matchsticks. The sky begins to snowglass. Tiny spherules hiss into lakes and lodge in gills. Light joke one, because even in bedtime stories we hold the smallest candle. Somewhere a very smug Ammonite thinks, finally, a plot twist, right before the plot twists it. Then comes the fire. The re-entry of incandescent debris turns the upper atmosphere into a broiler. Radiant heat pours downward, igniting leaf litter and brush, and in many regions whole forests catch as if they had been waiting for the cue. Smoke climbs into a ceiling that forgets how to let sunlight through. The ocean's warm at the top, even as the deeper waters chill in the dark. Food chains stall, carcasses drift. The air tastes like charcoal and sulfur. You can feel the chemistry turn. Sulfates from the region's gypsum-rich rocks vaporize into the atmosphere. When they condense, they seed sulfuric acid aerosols that reflect sunlight like a million extra dawns you never get to see. Global temperatures drop a sudden, bitter winter layered on top of the firestorm summer. Photosynthesis starves under a dimmed sun. The loud ones, the magnificent, sun-warm reptiles at the top of the food web, find that size and glory and very good teeth are poor currency when the bank of sunshine closes. Science fact to set gently on your nightstand: about 75% of Earth's species vanish at this boundary, including all non-avian dinosaurs. In the sea, ammonites go. On land, many flowering plant lineages stumble. In the air, pterosaurs bow out. But some theropod dinosaurs, small, feathered, seed-pecking opportunists, thread the eye of the needle. You will call their descendants birds and buy seed bells for them like offerings to a tenacious god. Scientists still debate the exact balance of killers. Was the asteroid alone sufficient, a single catastrophic strike that guaranteed darkness, cooling, acid rain, and famine? Or did the Deccan Traps eruptions in what is now India precondition the planet, with decades of volcanic gases and warming, setting the table for the final blow? Some teams argue for a 1-2 punch, climate stressed by eruptions, then lights out by impact. Others contend the impact was such an overhand swing that the setup hardly mattered. The rocks keep their counsel. The models argue in polite, high-energy voices. You drift over shorelines that don't recognize themselves. Fire scars checker the land. Ash muddies rivers. Winds carry a grey taste to places that never knew the Gulf. In what will one day be called North Dakota, fish will die with glass spherules trapped in their gills, a snapshot so immediate it reads like a diary today, the sky-snowed knives written in bone. The seas, stripped of plankton blooms, become quieter, bluer, emptier. Nights lengthen even at noon. Light joke too, the softest kind. Somewhere, a small mammal noses into a seed cache and thinks, finally, no one giant is stepping on my house today. It is not wrong. And yet, because Earth insists on "and yet," the catastrophe is not a full stop. It is a semicolon with terrible handwriting. In the ash, dim months and years that follow, survivors work the margins. In the water, hardy plankton that can eat dissolved carbon instead of sunlight keep the tiniest gears turning. On land, ferns, the world's emergency wallpaper, erupt in a global fern spike, colonizing burned ground like green bandages. In burrows, in leaf litter, in driftwood nests, mammals the size of rats and raccoons wait, breed, and experiment with diets that avoid starvation. Seeds, carrion, anything with calories and insufficient reflexes. Odd fact number 2. Within a few 100,000 years, a geological blink, the fossil record shows mammal body sizes trending upward, an evolutionary permission slip stamped by the vacancy of tyrants. Herbivores get heavier, predators get bolder, brain cases, in some lines, budget for upgrades. You think of how utterly different the sensory world becomes without 20-ton herbivores and 6-meter predators. Forests regrow with different architecture. The underbrush changes. Seed sizes shift when there are no giant sauropods to swallow them whole and drop them in new postal codes. Flowers lean into new pollinators. Insects retool. Rivers rework their banks under different hoofprints or the lack of them. An entire choreography resets its tempo. The crater itself cools under rain and time, its rim slumping, its central peak ring hiding under sediments like a secret. The atmosphere clears on a schedule written by physics more than hope. Sunlight returns in honest quantities. Photosynthesis sighs and sits up. Birds, those stubborn little theropods, test the wind again, their bones hollow and ambitions higher. The first true owls will one day watch with gold coins. For eyes as mammals lope through moonlit clearings, no tyrannosaur will ever cross again. Scientists still debate details large and small, the exact duration of the post-impact darkness, whether wildfires were truly global or patchy, how quickly marine ecosystems reassembled their food webs, whether winter or acid rain hurt more. The disagreements are not noise, they are the sound of attention. Meanwhile, the rocks keep offering receipts: iridium spikes, charcoal layers, soot, spherules, tsunami deposits like a ledger you can trace with careful fingers. Light joke 3. If Earth had a last seen page for whole clades, the non-avian dinosaurs entry would read, "Went out for a stroll 66 million years ago, left birds in charge, never returned." You rise, letting the battered planet fill your view. The silence feels deeper after great noise, and the blue looks truer after long dimness. You can almost hear the new rules clicking into place. Smaller first, flexible always, hide if you must, diversify when you can. The design has not been erased. It has been edited, and in the margin of that editorial note, a mammal somewhere is nursing young with a patience that will echo into lullabies. For a little while, you just breathe with the recovering world. The seas glitter shyly under a sun that remembers how to be kind. Fern fields ripple where forests will return. A bird alights on a blackened branch and shakes ash from its wings. The reign of dinosaurs has ended, but the story has not. It curls forward, warm-blooded and wide-eyed, toward futures that, improbably, will include you. The Earth is quieter now, but it's not an empty quiet. It's the pregnant pause between acts, the moment when the stagehands rearrange the scenery for the next performance. The dinosaurs' absence has left ecological rooms wide open, and the survivors, small mammals, birds, reptiles, insects, begin testing the furniture. At first, the mammals don't look like much. Most are no larger than a rabbit, many closer to a mouse. They live in burrows or dense vegetation, scurrying out to feed when it's safe. But freed from the shadow of giant predators and herbivores, they begin to diversify with an enthusiasm that borders on reckless. Some adapt to eat insects, others seeds, others leaves. Still others turn opportunistic, nibbling whatever fits in their mouths. Odd fact, within a few million years of the asteroid impact, the average mammal body size had increased tenfold. Not because they were chasing a fashion trend, but because there was space, ecological space to get bigger, to roam farther, to try new strategies. The world itself is rearranging. The continents, already drifting apart since the breakup of Pangaea, continue their slow migration. South America is still an island continent, home to marsupials and giant flightless birds. India is racing north toward Asia, a collision that will one day thrust up the Himalayas. In the seas, currents shift as land masses move, creating new climates and isolating populations. Evolution, always a tinkerer, uses these separations to craft new forms. Light joke 1. You could say the continents have been in long-distance relationships for millions of years, and it's definitely changed their personalities. Forests return in force. Angiosperms, flowering plants, expand into nearly every habitat, offering nectar, fruits, and seeds that reshape the diets of animals everywhere. Pollinators like bees, butterflies, and birds proliferate, painting the air with new colors and scents. Insects diversify explosively, and with them, birds refine their flight, honing beaks and wings for precise hunting or long-distance migration. Odd fact number 2. The earliest primates appeared during this time, around 55 million years ago, in the Paleocene-Eocene thermal maximum, a brief period of rapid global warming. They are small, tree-dwelling, and nocturnal, relying on large eyes to navigate through dense moonlit canopies. The mammals expand into roles once filled by reptiles. Hoofed herbivores evolved to graze open areas. Predatory mammals, creodonts, and early carnivorans prowl for prey. In the oceans, some mammals return to the water entirely, beginning the long transformation into whales. Imagine a wolf-like creature padding into the shallows for fish, generation after generation, until its descendants are streamlined giants, singing to each other across whole ocean basins. Scientists still debate how much of this diversification was inevitable after the dinosaurs' extinction and how much was helped along by changing climates, shifting continents, and plant evolution. Was this explosion of forms simply a matter of removing the old rulers, or was it the perfect storm of opportunity meeting capability? The fossil record suggests both. An empty stage is nothing without actors ready to improvise. From above, you can see the variety returning. Herds of early horses, no bigger than foxes, pick their way through forests. Dog-sized predators stalk in their shadow. In the treetops, primates with grasping hands leap from branch to branch, their tails curling for balance. Birds in every shade and pattern dart overhead, some chasing insects, others plucking berries. The land hums again, not with the thunder of dinosaurs, but with the layered activity of smaller, quicker lives. Light joke 2. If the Mesozoic was about loud, stomping spectacle, the Cenozoic starts more like an indie film. Smaller budget, quirkier characters, better chance of someone inventing coffee. The climate is warmer than today. Polar regions lush with forests instead of ice. Crocodiles bask in what will one day be the Arctic Circle. Tropical seas teem with corals and fish in shapes familiar to modern eyes. But the warmth will not last forever. Slowly, tectonic shifts will reconfigure ocean currents, and the Earth will begin a long cooling trend. Odd fact number 3. Antarctica, now the coldest place on Earth, was once covered in temperate rainforests, home to dinosaurs, then later to marsupials and early mammals. It only froze over about 34 million years ago, when the Antarctic circumpolar current formed. From your vantage point, you can sense the quiet boldness of this new era. Evolution is experimenting wildly. Some lineages will lead to elephants, others to bats, still others to humans. Most will vanish without fanfare, their genetic footprints disappearing into the sand. But for now, the world is a patchwork of experiments, a place where life is trying everything at once to see what sticks. Light joke 3. Somewhere, an early primate is figuring out how to use a stick to knock fruit down from a branch. It has no idea that, millions of years later, its descendants will use sticks to roast marshmallows. The age of dinosaurs is gone, but the Earth has not slowed. If anything, it seems to relish the turnover, spinning forward into an age where size matters less than adaptability, and where cleverness, whether in claws, wings, or brains, will decide who writes the next chapters. You hover there, watching the forests sway and the herds move, knowing that one day the descendants of these small survivors will stand on 2 legs and look back at all this, wondering how it ever began. The world is greener now, stitched together with forests, grasslands, and winding rivers. The giant reptiles are long gone, their bones turned to stone, but the Earth is still in motion, continent against continent, sea currents shifting like restless thoughts. It is a time of ice and mind. The ice doesn't come all at once. First, mountain ranges rise higher than they have in millions of years. The Himalayas thrust skyward. As India finishes colliding with Asia, the Andes stretch along South America's spine, and ranges in North America push toward the clouds. Taller mountains change wind patterns, wring moisture from the air, and feed glaciers at their peaks. These glaciers grow, creep downhill, and over time join into vast ice sheets. The polar regions cool. The world's thermostat is being turned down notch by notch. Odd fact. by about 2.6 million years ago, Earth has entered the Pleistocene, an epoch defined by repeating ice ages. Gigantic glaciers cover up to a third of the planet's surface, some kilometers thick, heavy enough to depress the crust beneath them like a thumb on soft clay. From above, you watch the ice march. It advances slowly meters per year, but relentless, sculpting the land beneath it. Valleys are widened into U-shapes, lakes carved from bedrock. When the ice retreats, it leaves behind boulder fields, moraines, and the glittering fingerprints of meltwater rivers. Each advance and retreat reshuffles the map, creating new paths for animals and plants, new challenges for survival. This is the age of the megafauna. On the open plains, herds of mammoths move like shaggy living hills, their curved tusks gleaming pale against the tundra. Woolly rhinoceroses trudge through snow-dusted grasslands, while giant ground sloths haul their bulk upright to strip leaves from low trees. In the warmer parts of the world, saber-toothed cats stalk camels and bison, their long canines glinting with every breath. Light joke 1. If you'd been here with a camera, you could have made the ultimate wildlife documentary, though you'd have to carry a spear just in case the stars decided to charge the director. The ice ages are not constant winters. They pulse glacial periods lasting tens of thousands of years, followed by interglacials when the ice recedes, forests regrow, and animals expand their ranges. Sea levels rise and fall by over 100 meters between these phases, exposing land bridges like Beringia between Asia and North America, then drowning them again under the swelling seas. These shifting pathways allow animals and eventually humans to migrate to new continents. Odd fact number 2. DNA evidence shows that woolly mammoths and Asian elephants are more closely related to each other than African elephants are to either group. It's a reminder that the divisions we see today don't always match the family trees of the past. The humans, Homo erectus, Homo heidelbergensis, and later Homo sapiens arrive in this icy theatre as small, clever, adaptable players. They learn to use fire against the cold, shape stone into tools, and work together to bring down prey many times their size. They wear the skins of the fallen as armor against the wind. Their migrations are timed with the shifting climates, following herds across frozen rivers and open plains. Scientists still debate the exact role humans played in the disappearance of much of the megafauna at the end of the last ice age. Was it hunting pressure, rapid climate warming, or a combination of both? The evidence is a jigsaw puzzle, and each new fossil, pollen record, or DNA fragment adds a piece. From your vantage point, you can see how the ice and the mind shape each other. The challenge of surviving harsh winters forges cooperation, planning, and innovation. Camps cluster near rivers, stone tools litter the ground like quiet signatures, cave walls glow with painted mammoths and bison, proof that imagination is now a survival tool. Light joke 2. Somewhere, a human is explaining to another human that their mammoth painting is abstract, which is just prehistoric code for "I can't draw legs very well." The end of the last glacial period, about 11,700 years ago, is abrupt in geological terms. Ice sheets retreat for the final time, at least for now, and the climate warms into the relatively stable Holocene. Forests reclaim the tundra, rivers swell, and humans shift from roaming hunters to settled farmers. The great herds shrink and vanish. Mammoths hold out in isolated refuges like Wrangel Island for thousands of years after their mainland kin are gone. Odd fact number 3. When the last population of woolly mammoths disappeared about 4,000 years ago, the pyramids of Egypt were already standing. From the sky, the change is striking. Ice retreats to the poles, leaving behind a world etched with its handiwork fjords, glacial lakes, broad valleys. Humans spread into every continent except Antarctica, carrying with them seeds, livestock, and stories of the ice. The megafauna that remain adapt to smaller ranges, their ghosts preserved in fossils and myth. Light joke 3. The Ice Age didn't end because someone forgot to pay the snow bill, but it's tempting to imagine. The glaciers may have melted, but their influence lingers in the shape of the land, the paths of rivers, and even the genetic code of humans who still carry adaptations to cold. You drift higher, watching the planet breathe easier in the warmth, knowing that the ice will come again someday. It always does, and that when it does, whatever life remains will once more learn how to endure. The ice has pulled back, the rivers are running full, and the air smells of wet soil and new leaves. The continents wear their post-glacial clothes, broad floodplains, young forests, and coastlines pushed far inland compared to the icy past. It's in this softer, warmer world that humans begin doing something no other species has done at this scale. They start shaping the planet on purpose. It begins simply enough. People discover that seeds dropped near camp grow into food plants. They learn to tend those plants, to choose the ones with the fattest grains or the sweetest fruit. In parallel, they take animals from the wild sheep, goats, cattle, dogs, and breed them for traits that suit human needs. Agriculture and domestication spread like a quiet revolution, transforming landscapes from wild meadows to organized fields. Odd fact: the earliest known evidence of bread making comes from around 14,000 years ago, thousands of years before the formal advent of farming. It seems humans couldn't resist turning grains into something chewy and fragrant even before they were planting them deliberately. The change is visible from above. Where there were once forests or wild grasslands, geometric patterns emerge: fields bounded by stone walls, irrigation channels glinting in the sun. Villages appear, then towns, then cities, their roads radiating like spokes from central markets or temples. Smoke rises from hearths in steady columns. Rivers are crossed by wooden bridges. Hills bear the scars of quarries and terraces. Light joke 1. If Earth had a before and after photo for this era, the caption might read, "From wilderness to weirdly straight lines." With farming comes surplus food, and with surplus food comes specialization. Not everyone has to hunt or gather anymore. Some can make tools, weave cloth, trade goods, or keep records. Written language emerges in different places: cuneiform in Mesopotamia, hieroglyphs in Egypt, oracle bones in China, each one a way to store ideas outside the fragile vault of memory. Odd fact number 2, the first known written word for city in Sumerian translates loosely to big settlement of humans, which feels charmingly obvious, as if they were still surprised by the concept themselves. Civilizations rise along rivers: the Nile, the Tigris and Euphrates, the Indus, the Yellow River. Water is both a resource and a highway, carrying goods, stories and people. Monumental architecture begins: ziggurats, pyramids, stone circles built with mathematics that will later impress architects who think they invented precision. Trade networks span continents, exchanging not just goods, but languages, technologies, and diseases. Scientists still debate whether agriculture was an inevitable development once humans reached a certain population density, or whether it was a choice driven by climate shifts at the end of the last ice age. Was it necessity, convenience, or ambition that made humans settle down? The evidence suggests a mix. Different communities tried, different approaches, and the ones that stuck became the backbone of history. From your vantage point, the human influence is impossible to miss. Forests are cleared to make way for crops. Wetlands are drained. Rivers are diverted to feed thirsty fields. Domesticated animals graze in numbers far beyond their wild ancestors, reshaping plant communities through sheer appetite. The planet's biosphere begins to reflect not just the slow processes of geology and climate, but the accelerating decisions of a single species. Light joke 2. Earth has had 5 great mass extinctions caused by nature. This is the first time one species has started doing the paperwork for a 6th. Odd fact number 3. Domestication changes both species involved. Dogs evolved to read human gestures and facial expressions, while humans evolved extra copies of the amylase gene to digest more starch from cultivated grains. Farming didn't just change the landscape, it rewired the biology of the farmers. Cities grow denser, roads stitch them together, empires rise and fall, leaving behind ruins that will someday be studied by strangers trying to piece together the logic of lost maps. In some places, humans work with the land's contours. In others, they bend it into new shapes, cutting terraces into mountains, channeling water uphill, or building artificial islands. Light joke 3. Humans like to think of themselves as masters of nature, but half their inventions are just clever ways to get around not wanting to walk uphill for water. From above, the patchwork of human influence is beautiful and unsettling at once. Golden fields ripple in the wind, canals glitter, smoke spirals upward. Yet every change leaves a mark: soil depleted by over-farming, forests reduced to scattered patches, rivers burdened with silt. It is a new kind of planetary design, one where intention is as much a driver as accident. You hover higher, watching the sun set over a world that is no longer only a product of natural forces. Fires burn in hearths, lamps flicker in windows, voices carry over stone streets. The age of ice and megafauna has passed. The age of human shaping has begun. It will bring wonders, it will bring ruin, and it will leave behind a record of choices written not just in books, but in the very bones of the earth. From this height, the human-made lines spread like veins, roads, aqueducts, trade routes that shimmer under the sun and vanish into night. You can almost trace history in the way they fork and braid. The Silk Roads unfurling across Asia, Roman highways laid in straight defiance of terrain, caravan trails etched by countless hooves. But just as the land carries these marks, the seas carry invisible ones, currents now stitched with the wake of ships. Sails bloom across coastlines like seasonal flowers. Phoenician traders ride the Mediterranean winds. Austronesian navigators read the Pacific swells with the memory of stars. Arab dhows slip between East Africa, India, and Arabia with monsoon precision. Goods move spices, silk, copper, obsidian, but so do ideas, faiths, and diseases. The Earth's design now includes human exchange as a geological force, reshaping landscapes without lifting a single stone. Odd fact: by the year 1000 CE, there were already trade networks linking Scandinavia to the Indian Ocean through rivers, seas, and overland caravan trails, a planetary web spun without engines, satellites, or steel. Cities thicken, and some swell into megacities for their time. Chang'an, Baghdad, Tenochtitlan, each a knot of commerce, politics, and culture. The air above them smells of hearth, smoke, wet stone, and human closeness. From above, their lights, whether fire or oil, looked like constellations reflected on the ground. Light joke 1. If the gods were looking for an excuse to confuse humans, they could have just rearranged the constellations every few decades. Humans seem to do that on the ground anyway. Empires emerge and fracture: Han, Abbasid, Byzantine, Inca, Mali. Each leaves behind roads, irrigation systems, and architectural signatures carved into rock and memory. Forests fall to feed armies and fleets. Fields expand to feed cities. The human footprint deepens, but it's not just in removal: terrace farming greens mountainsides, Carnets carry water through deserts, windmills turn air into work. Scientists still debate the exact onset of what some call the Anthropocene, the epoch in which human activity rivals geological processes in shaping the planet. Some point to the Industrial Revolution, others to the Columbian Exchange after 1492, when crops, animals, and diseases leapt between hemispheres, permanently mixing the world's biota. Corn, potatoes, and tomatoes from the Americas transformed diets in Europe, Africa, and Asia. Wheat, horses, and cattle crossed the Atlantic in the other direction. Odd fact number 2. Within a century of European arrival in the Americas, the population collapse from introduced diseases was so massive that abandoned farmland reforested, drawing down enough carbon dioxide to slightly cool global temperatures, a little ice age written in trees. The pace of change accelerates. Coal furnaces, steam engines, and spinning jennies multiply production and pollution alike. Railroads stitch continents tighter. Telegraphs turn communication from a matter of weeks to minutes. Cities grow vertically, stone giving way to steel. From your vantage point, night reveals a new map, an archipelago of lights marking industrial hubs, their glow pooling along coasts and rivers. Light joke 2. The stars must have been relieved finally. Someone else gets to do the twinkling for a while. Industrialization comes with costs the builders don't yet fully measure. Rivers run black with dyes. Smokestacks lace the air with soot. Forests shrink to make way for mines and mills. Yet alongside the harm, knowledge blooms. Geology charts the Earth's layers. Chemistry maps the elements. Medicine lengthens lives. Human curiosity, once limited to the horizon, now reaches into the strata below and the clouds above. Odd fact number 3. The first photograph of Earth from space was taken in 1946, not by astronauts, but by a camera on a captured German V-2 rocket launched from New Mexico, an accidental dawn of our planetary self-portraiture. By the 20th century, the scale tips, oil, plastic, and concrete, become the new trilogies of human reshaping. Highways slice through mountains, canals splice seas, and dams stop rivers mid-stride. Skyscrapers mimic cliffs. Cities sprawl in fractal patterns visible from orbit. Airplanes trace contrails through the upper atmosphere, erasing the old isolation of continents. Light joke 3. If Earth had an address book, by now it would just say, "Same house," but my roommates have filled the whole place with furniture. From above, the design of the planet is now part geological, part biological, part intentional, though intentional varies in clarity. You can see the straight geometry of farmland contrasting with the winding chaos of rivers, the perfect arcs of artificial harbors meeting the jagged lines of old volcanic coasts. Even deserts bear human marks, grids of irrigated fields blooming green against tan, solar farms reflecting the sky like glass lakes. Scientists still debate how much of this reshaping can be sustained. The same ingenuity that built cities and networks has altered climate patterns, melted glaciers, and pushed countless species to the brink. But history suggests that humans rarely stop at noticing a problem. They tend to try solving it, for better or worse, with inventions that ripple in ways they don't predict. From your high perch, you watch as satellites join the night sky, orbiting above the same cities whose lights they help guide. Radio waves hum upward. GPS signals weave invisible nets around the sphere. Earth is now self-aware. In a literal sense, its inhabitants can see themselves from space, measure the carbon in the air, and track the retreat of ice in real time. It is still the same planet, but the design has entered a new phase 1, where the designers are part of the blueprint, shaping and being shaped in return. The question is no longer how Earth was designed, but how those now holding the pencil will choose to draw the next lines. From this high, quiet vantage, the oceans are a deep, breathing blue. They've been here from the beginning, born from vapor and comet ice, and yet now they are busier than ever. Invisible currents loop the globe like the arteries of a restless heart, moving heat, salt, and nutrients in a slow but constant cycle. These are the ocean's secret engines, the designs you don't notice until they fail. Near the surface, sunlight sparks the great floating forests of phytoplankton. These microscopic plants feed almost everything else directly or indirectly and exhale oxygen into the air you're breathing right now. From space, their blooms appear as swirls of turquoise and jade, tracing eddies where warm and cold waters meet. Odd fact: despite covering over 70% of Earth's surface, the oceans produce more than half of the planet's oxygen. Without them, the air would thin in silence. Light joke 1. If the oceans ever stopped making oxygen, forests would have to take double shifts and they'd probably file a formal complaint about overtime. Below the light zone, life changes its strategy. The twilight zone, 200 to 1,000 meters down, is home to creatures that make their own light. Lanternfish, hatchetfish, squid with headlights in their skin. Every night, billions of these animals rise toward the surface to feed, then retreat by dawn. This vertical migration is the largest daily movement of life on Earth, and most humans have never seen it. Deeper still, in the midnight zone, the water is near freezing, the pressure immense, and the darkness absolute. Here, the rules of design are bent jaws, unhinged to swallow prey as big as the predator itself, and bodies become gelatinous to withstand crushing depths. At hydrothermal vents, along mid-ocean ridges, mineral-rich water gushes into the cold, and entire ecosystems thrive without sunlight, fueled by bacteria that turn chemicals into energy. It is, in a way, a mirror of Earth's earliest life heat and chemistry meeting in the dark. Scientists still debate how much the oceans regulate climate through these hidden systems. The Great Conveyor Belt of thermohaline circulation, for example, takes about 1,000 years to complete a full loop, moving warm water from the tropics toward the poles and returning cold, nutrient-rich water to the equator. Interrupt it, say, by melting too much ice into the North Atlantic, and you could scramble weather patterns across the globe. Odd fact number 2. The ocean's deepest known point, Challenger Deep in the Mariana Trench, is nearly 11 kilometers down, deeper than Mount Everest is tall. If you dropped Everest into it, the summit would still be over 2 kilometers underwater. From above, the surface looks calm, but the oceans are threaded with human marks, shipping lanes etched in GPS lines, fishing fleets glowing in the dark like constellations on the wrong canvas, oil platforms standing like steel trees in the shallows. These activities are changing the oceans in ways the planet hasn't seen before. Overfishing alters entire food webs, warming waters, bleach coral reefs, and excess carbon dioxide dissolves into the seas, making them more acidic. Like joke 2, we've managed to give the ocean heartburn, and unlike us, it can't just take an antacid. Yet the oceans are resilient. Mangrove forests anchor coasts against storms. Kelp forests grow faster than almost any plant on land. Whales, once hunted to the brink, are returning in some regions, their migrations again spanning entire hemispheres. Each time a whale dives, it stirs nutrients from the depths, helping plankton grow, a reminder that even the largest creatures serve the smallest. Odd fact number 3. Blue whales, the largest animals ever to live, eat tiny krill by the ton. It's proof that you can be the size of a city bus and still live off shrimp cocktails. From your vantage point, you can see how the oceans connect every shore. A storm in the Pacific can send swells to the Americas and Asia. A volcanic eruption in Tonga can send pressure waves around the globe. The seas are the planet's oldest network, one that existed long before humans built ships or cables to cross them. Scientists still debate whether the ocean's capacity to absorb carbon and heat will protect us from the worst effects of climate change, or whether it's already nearing its limit. The answer matters because everything, weather, food, breathable air, depends on how this vast system behaves in the coming decades. Light joke 3. If the ocean had a resume, keeps Earth habitable, would be under other duties as assigned. You linger over the shifting blues, watching currents curl into spirals thousands of kilometers wide. The moon still tugs at the tides, just as it did billions of years ago. The same pull that once stirred chemistry in tidal pools now sways entire coastlines. The design is ancient, but still in motion, still making room for life in all its improbable forms. And as you drift higher, the Earth's oceans seem less like features of the planet and more like the planet's beating heart, steady, vast, and essential. From this height, the planet glows faintly in the dark, a mixture of moonlight on clouds and the thin blue halo of atmosphere. You've seen Earth's forests, mountains, and oceans, but there's a shield here you can't see with your eyes, a quiet guardian that's been at work since the molten heart first began to spin. It's the magnetic field, an invisible force that shapes life's possibilities more than most realize. Deep beneath the crust, the liquid outer core churns. It's mostly molten iron and nickel, spinning and swirling under the influence of Earth's rotation. These movements create electric currents, and those currents generate the magnetic field, a planetary dynamo, humming away without pause. Odd fact, this geodynamo is so powerful that it extends tens of thousands of kilometers into space, forming the magnetosphere, a bubble that deflects most of the charged particles streaming from the sunday. Without this field, solar wind would strip away the atmosphere over time, just as it likely did to Mars. The loss of air would mean the loss of oceans, and without oceans, the story of life would have been very short indeed. In a way, every breath you take is on loan from the magnetic field's patience. Light joke 1. If the atmosphere is Earth's blanket, the magnetic field is the friend who keeps shaking it out to make sure no cosmic crumbs get in. The magnetosphere isn't a perfect wall, it's more like a shield with a flexible edge. Some particles slip in near the poles, funneled along magnetic lines, where they collide with molecules in the upper atmosphere and create the auroras. From above, these lights ripple and twist in green, red, and violet, like the planet wearing scarves of silk in the solar wind. Scientists still debate the details of how the geodynamo began. Did the core crystallize in stages? Was early Earth's faster spin essential to starting it? And how long can it keep running? The field has reversed polarity many times in the past north, becoming south and back again without catastrophe. But the timing and triggers of these reversals remain puzzles in paleomagnetism. Odd fact number 2. The most recent reversal, the Brunhes-Matuyama event, happened about 780,000 years ago. If you had a compass back then, its needle would have pointed south. From your vantage point, you see how the field interacts with the sun's moods. During solar storms, the magnetosphere flexes and flares, absorbing the impact. These storms can rattle power grids, disrupt satellites, and paint the skies with unusually vivid auroras far from the poles. The field is not static, it shifts over time. The magnetic poles wandering across the surface at speeds of tens of kilometers per year. Beneath the surface, the molten core's movement is influenced by heat escaping from the inner core, by the rotation of the planet, and even by the slow creep of mantle convection above it. This is Earth's longest-running machine, operating at scales so large that continents and oceans are just thin frosting above the gears. Light joke 2. The magnetic field is like Wi-Fi. You can't see it, most people forget it's there, but without it, life would get a lot more difficult very quickly. Odd fact number 3. Birds, sea turtles, and even certain bacteria can sense the magnetic field, using it for navigation. In a way, they're reading a map that was drawn by molten metal before their ancestors existed. From orbit, satellites measure every twitch of the field, mapping regions where it's stronger or weaker. One such weak spot, the South Atlantic anomaly, causes more cosmic radiation to reach low Earth orbit, occasionally glitching satellites that pass through. Scientists watch it closely, wondering if it's a sign of deeper changes in the field's structure. Still, despite its fluctuations, the field has endured for billions of years, a constant silent partner in the planet's habitability. Without it, Earth might have been just another barren rock in the sun's collection. With it, oceans, forests, and civilizations have had the time to grow, collapse, and grow again. Light joke 3. If Earth could speak, it might brag to Mars, "I still have my atmosphere because I remembered to keep my core spinning." You drift a little higher, watching the auroras shimmer over the poles, silent to your ears but electric to the eyes. The glow is both warning and reassurance, a sign that the solar wind is out there, and that something invisible is meeting it head-on. The same molten heart that once glowed red at the planet's birth is still working, still shielding, still making this blue world possible. In that light, the magnetic field feels less like a feature and more like a promise one Earth has kept for billions of years without ever asking for thanks. From your high perch, the planet turns beneath you, steady and sure. The continents, oceans, and skies all follow their own slow rhythms, but there's another rhythm here, quieter, invisible, and older than any city or forest. It's the rhythm of the orbits, the mathematics of motion that keeps Earth exactly where it needs to be. The sun holds Earth in its gravity like a stone in a sling, pulling it along an elliptical path that repeats every 365 and a quarter days. Odd fact, that extra quarter day is why we have leap year's tiny course corrections in the calendar to keep the seasons from sliding away from the months. Without them, summer in the northern hemisphere would drift into January over millennia, and ski resorts might be advertising beach umbrellas. The Earth's orbit isn't a perfect circle, but the slight oval shape combined with a steady tilt of about 23.5 degrees creates the seasons. This tilt is a kind of cosmic bias, ensuring that no single latitude hogs the sun's warmth all year. Without it, much of the planet would hover in a perpetual mildness, but the poles would freeze eternally, locked in ice no summer could melt. Light joke 1. The tilt is basically Earth's way of saying, I like variety. Without it, holiday postcards would all look the same. Scientists still debate exactly how stable this arrangement will be over tens of millions of years. The orbits of the planets tug at each other constantly, tiny gravitational nudges adding up. Over long timescales, Earth's tilt, orbital shape, and wobble, precession, change in predictable cycles known as Milankovitch cycles. These cycles, lasting tens to hundreds of thousands of years, are believed to be major triggers for ice ages and warm periods. Odd fact number 2. Right now, Earth is about as circular in its orbit as it ever gets. In 100,000 years, it'll be slightly more stretched out, subtly changing how sunlight is distributed between seasons. From above, you can see how the moon joins in the orbital ballet. It tugs at Earth's oceans, creating tides that rise and fall with patient precision. These tides also act as a brake, gradually slowing Earth's rotation over millions of years and pushing the moon farther away. The days are getting longer, but so slowly that it will be billions of years before they're noticeably different to human schedules. The interplay of orbits is a balancing act. Earth's distance from the Sun places it in the habitable zone, where liquid water can exist on the surface. Move it much closer, and oceans would boil much farther, and they would freeze. Venus, just one step inward, became a sweltering greenhouse. Mars, a step outward, lost most of its atmosphere and water. That Earth sits in the sweet spot is the result of cosmic luck and gravitational mathematics working in quiet concert. Light joke 2. In real estate terms, Earth is in the perfect neighborhood, close enough to the Sun for warmth, far enough to avoid spontaneous combustion. Odd fact number 3. Earth doesn't actually orbit the exact center of the Sun. It orbits a shared center of mass that is slightly offset because the Sun wobbles under the gravitational pull of its planets. Even the biggest player in the solar system can't ignore the smaller ones. From here, the predictability is almost soothing. You can map the future of eclipses centuries ahead, predict the precise second the Sun will rise anywhere on Earth, and track the dance of planets with clockwork certainty. Yet there's a fragility in that. Precision asteroid impacts, shifts in mass distribution, or even a rogue planet passing nearby could alter the choreography. Scientists still debate how much the stability of Earth's orbit contributed to life's complexity. Some models suggest that too much wobble or eccentricity would have kept climates volatile, favoring only the simplest life forms. Others think life might adapt regardless, finding pockets of stability in the chaos. Light joke 3. If Earth had a dating profile, under strengths, it would list stable long-term relationships with the Sun and Moon. You drift lower, feeling the hum of this orbital harmony. The Sun's light is not just heat, it's the engine driving weather, seasons, and the energy in nearly every bite of food. The Moon's pull is not just a tide, it's a rhythm that shapes coastal ecosystems and perhaps even guided early life toward complexity. These orbits aren't just geometry, they're the clock and the metronome of the living world. As Earth completes another silent lap, you realize that this balance, gravity, distance, tilt, and time isn't just part of the planet's design, it is the frame in which the entire story of life is painted. And for now, at least, the frame is steady. From up here, you can see the whole patchwork glaciers still clinging to mountaintops, rainforests fanning out in green spirals, deserts stretching in quiet ochre. But there's something in the pattern that stands out. It's not perfect. The planet's design is full of mismatched seams, lopsided arrangements, and landscapes that seem to contradict each other. And somehow, it's this imperfection that makes Earth resilient. Take deserts. From the Sahara to the Gobi, they are places where water is stingy, where plants survive by hoarding or by surrendering entirely. Yet these barren spaces are cradles for unique species camels that can sip water into memory, desert foxes with ears like satellite dishes to lose heat, seeds that wait decades for the right rain to wake. The emptiness shapes the ingenuity. Odd fact, the Atacama Desert in Chile is so dry that some weather stations there have never recorded a single drop of rain. Yet cyanobacteria live in rocks there, sheltered from the sun but still photosynthesizing with what little light slips through. On the opposite extreme are rainforests, where life is so abundant that competition is fierce. Trees race upward in thin trunks to reach sunlight, their branches supporting entire aerial ecosystems. Ants farm fungi, birds carry seeds, orchids trap rainwater in their leaves to make ponds for frogs. In the Amazon, a single square kilometer can host more tree species than the entire country of Canada. Light joke 1. If the desert is Earth's minimalist, the rainforest is its maximalist. One likes bare shelves, the other fills every inch with souvenirs. Mountains tell the same story of imperfection as design. They're the result of collisions, breaks, and folds in the crust, geological accidents that seem almost violent. Yet they create microclimates, influence rainfall, and serve as reservoirs for rivers that feed millions. Without their jagged edges, much of the world's fresh water would vanish in dry seasons. Scientists still debate whether these extremes, hot and cold, wet and dry, high and low, are necessary for biodiversity to flourish. Some argue that stable, uniform environments would produce more consistent life. Others point to the evolutionary pressure of hardship as the spark that drives adaptation. The consensus leans toward variety. The unevenness of Earth's landscapes creates niches, and niches create life's variety. Odd fact number 2. The Himalayas are still rising today at about 5 millimeters per year, the result of India's ongoing collision with Asia. The planet's largest mountain range is not a finished product, it's a construction project still in progress. From above, the patchwork is in motion. Deserts expand or shrink with climate shifts. Glaciers melt, revealing valleys that haven't seen sunlight in thousands of years. Forests regrow in abandoned farmland. Volcanic islands rise from the sea, bare at first, then draped in green. The imperfection isn't static. It's a living, changing set of opportunities and challenges. Light joke 2. Earth is basically that friend who redesigns their apartment every time you visit, sometimes for better, sometimes for worse, but never the same twice. Oceans, too, have their mismatched edges. Warm and cold currents weave together in uneven patterns, sometimes feeding life in great abundance, sometimes leaving entire stretches of coast nutrient poor. Coral reefs thrive in certain pockets of warm water, creating riotous gardens of color, while just beyond them, the seafloor might be a barren plain. The patchiness forces movement, fish, plankton, and predators all migrate, ensuring constant mixing of genes and resources. Odd fact number 3. The richest fishing grounds in the world, like the Grand Banks or the upwelling zones off Peru, exist because currents bring cold, nutrient-rich water to the surface in just the right places. Without these quirks, the oceans would be far poorer. Scientists still debate whether Earth's irregular design is simply luck or the inevitable result of physics and chemistry. Was it chance that mountains formed where they did, that continents drifted into their current shapes, that deserts and rainforests share the same planet? Or was variety bound to emerge on any world with liquid water, an atmosphere, and time? From your vantage point, you can see how the mismatches connect. A glacier's meltwater feeds a desert river, which creates a green ribbon of life across sand. A volcanic eruption destroys a forest, but the ash enriches the soil for centuries. A storm strips a coastline bare, only to create tide pools where new species find refuge. It's not a tidy design, but it's one that works because it's flexible. Light joke 3. If perfection means nothing left to change, Earth clearly never got the memo. You hover higher, letting the uneven beauty fill your vision. There's no symmetry here, no single organizing rule that explains every mountain, current, or storm. But maybe that's the point. The irregularities are not flaws. They are the spaces where life learns, adapts, and surprises itself. The planet's beauty lies in the fact that it was never aiming for perfection. From the quilt of deserts and rainforests and mountains still stitching itself under slow geologic fingers, you notice a sharper thread, straight lines, right angles, bright veins of light. The planet's irregular beauty has acquired a new overlay, and you can feel the intent inside it, the way a city grid hums with somebody's idea of order. This is the human blueprint, laid carefully and sometimes carelessly across the old, lopsided masterpiece. It begins with the simplest drafts: a levee along a floodplain, a terrace cut into a hillside, a canal persuading a river to change its mind. You hover over a delta and watch the water split, braid, and then submit to concrete. Bridges leap gaps that once required patience. Roads decide that hills should be negotiated by switchbacks and that swamps should be crossed on stilts. A farmhouse becomes a village. The village shuffles into a town. The town practices being a city until it can hold 1,000,000 small plans at once. You drift through the evening over a metropolis after rain, and it gleams like circuitry, the storm flushed into storm drains, the storm drains into tunnels, the tunnels to the river to the sea. Humans have learned to move water as if it were a paragraph to be edited. Cut here, add there, please be concise. It works beautifully until it doesn't, and then the paragraph floods the basement in a fit of punctuation. Still, you see the grace when it comes together. Cisterns under parks, green roofs that sip the sky, wetlands stitched back along the edges to catch the overflow. Science fact to set gently on the drafting table. Each year, humans now move more rock and soil than all the world's rivers and glaciers combined. Roads, mines, foundations, and fields shifted by the billions of tons, an unmistakable signature in the stratigraphy. The blueprint isn't metaphor, it's sediment. Odd fact, by around the year 2020, the mass of human-made stuff, concrete, steel, plastic, asphalt, was estimated to outweigh all living biomass on Earth. Somewhere, a forest cleared its throat as a polite reminder that the original materials came first. You skim along shorelines that have been taught new shapes, seawalls that take the punch out of storms, mangrove restorations that turn grey coasts green, breakwaters that invite coral to return to the party. The language of design has borrowed back from nature, sponge cities that soak up rain, daylighting of buried creeks so they can breathe again, buildings that twist like shells to confuse the wind into gentleness. Even the glass learns new manners, angled to keep birds from mistaking the sky for a trap. Light joke 1. Somewhere an engineer is presenting a plan labeled "humble imitation of beavers," and the beavers are like, finally, some credit. Inside the grid, the blueprint multiplies. Zoning maps, utility schematics, subway diagrams, fiber routes, layers upon layers, each its own quiet empire. Hospitals map flows of people and air. Schools map curiosity by age. Markets draw invisible rivers of food through refrigerated veins. You can stand on a corner and feel the choreography. Lights shifting, buses huffing, pigeons negotiating air rights with hawks, a child tugging a parent toward a bakery, which is also a small power plant if you count the yeast. The materials portfolio grows. Concrete that heals its own cracks with bacterial blooms. Asphalt that drinks heat by day and exhales it slowly at night. Timber grown to rival steel in strength, but lock carbon away like a lullaby pressed into grain. Designers steal from termite mounds to ventilate towers, and from whale fins to shape wind turbine blades. They steal from forests to imagine districts that cycle water and nutrients like ecosystems instead of machines that just happen to be indoors. Scientists still debate how far we can push this biomimicry before we simply rename ecology as engineering and forget the part where living systems break, adapt, and forgive. Is a city a forest with better coffee, or does it need the soil, fungi, and patience that forests insist upon? You can feel the answer hovering between lanes of traffic like heat. Light joke 2. Urban planners will tell you every street should be a living room. Drivers will tell you every street is a racetrack. Pedestrians will tell you every street is a moral test. You rise to see the planetary scale of the draft. Power grids arc from windy plains to office towers, from river dams to laundromats, from rooftop panels to kitchen kettles that sing in the morning. Satellites, tiny metal moons, thread timing through shipping cranes, ambulances, and farm tractors that steer by constellation. A harvest drone lifts, reads moisture in leaves, then whispers to an irrigation valve 5 kilometers away. Somewhere, a wastewater plant is turning yesterday's shower into tomorrow's tomatoes, and the tomatoes are busy pretending they don't know. The blueprint is not only steel and stone, it's agreements. Treaties that decide who may fish where and when. Compacts that split rivers among cities that didn't exist when the river learned its path. Corridors set aside so elephants can remember the way their great-grandmothers walked. You can chart these decisions from space by the way forests stop at borders, or flow across them, by the way a dark river suddenly brightens where a dam spills its electricity into hunger. Then there's the nervous system humming in your pocket, code that moves money, ideas, and solace at the speed of fingertips. Markets pulse, storms are tracked days out. A mother watches her child cross a city on a blinking dot. A researcher on one continent reads the heartbeat of a coral reef on another and frowns gently at the numbers. The blueprint has become reflexive. It measures itself, critiques itself, sometimes fixes itself before breakfast. And yet, because the human blueprint shares the planet with weather, geology, and luck, it cracks. Suburbs baked under heat domes rewrite their lawns as prairie. Cul-de-sacs sprout shade trees like apologies. Rivers ask for their floodplains back in firm, wet handwriting. Coasts learn to roll inland with dignity, and the most successful designs begin to include movement as a feature, not a failure. Retreat becomes a plan instead of a panic. You pause over a neighborhood that decided to breathe differently. Curbs are carved to let stormwater into gardens. A school roof wears solar panels like a chessboard. The supermarket's parking lot has learned a new trick. In a blackout, it becomes a microgrid, a lantern for a square mile of dinners. Buses whisper past on batteries, and the street trees have little bracelets of soil monitors, as if they were patients whose health is suddenly the family priority. Light joke 3. If cities are living organisms, zoning meetings are the digestive tract necessary, occasionally noisy, and you only appreciate them when something goes wrong. The debate continues, of course it does. Scientists still debate whether net zero cities can truly balance their books, or whether the math hides the outsourced mess in someone else's backyard. They argue about geoengineering, about carbon capture that sips from smokestacks or drinks the sky directly, about rewilding the edges so foxes and teenagers both have somewhere to disappear for a while. Disagreement here is not failure. It's the sound of a species trying to edit a draft while the book is already at the printer. In the gentler lanes of night, you watch people write smaller blueprints, a shared tool shed on a block where drills are borrowed like sugar, a staircase widened so a wheelchair and a stroller can pass with smiles, a library that stays open late because quiet is also infrastructure. The grand designs matter, but the tiny ones work closest to the skin. You feel your shoulders lower at the sight. The old earth is still underneath, the fault lines that do not care about schedules, the wetlands that will take back their water unless offered a patient place to sit, the winds that cut corners on their way to the horizon. The best human designs begin to fold those truths in, like bakers coaxing air into dough rather than hammering it flat. Flexibility replaces certainty. Margins replace edges. Redundancy replaces bravado. When you rise again to see the whole, the blueprint doesn't look like a takeover so much as a conversation finally getting interesting. Rivers are straighter than they would be alone, yes, but also cleaner, in stretches where someone remembered that fish are citizens. Towers scrape the sky, yes, but some of them feed the grid in reverse, and some hum with gardens 50 floors up where bees learn to love altitude. The human plan is still young, often clumsy, sometimes loud, and frequently late, but in its better pages, it reads like care. You let that settle. The world below is a negotiation between rugged geology, mercurial weather, stubborn biology, and people with pencils. The lines won't ever be perfect. That was never the point. The point is to draw in a way that leaves room for rivers to wander, for children to grow, for owls to find the dark they deserve, and for mornings that smell like bread and rain. From the weave of rivers and roads, from the patchwork of deserts and towers, your gaze begins to slip deeper, not into the crust this time, but into the invisible architecture that runs through every leaf, every lung, every drop of rain. You're looking at the chemical blueprint, the molecular design that underpins the planet's personality. Here, nothing is still. Atoms rush to swap partners, electrons leap between bonds, energy moves in packets so small you could stack trillions inside a raindrop and still have room for a little dust. The periodic table is the planet's alphabet, and life writes its stories in carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. The rest of the elements make cameos, often brief but essential: iron in blood, magnesium in chlorophyll, iodine in a thyroid gland that prefers to stay anonymous. Science fact: the iron in your blood and the calcium in your bones were forged in ancient stars that exploded long before Earth existed. You are literally stitched together from stardust, wearing it like it's just skin and not the debris of a supernova. Odd fact: every breath you take contains at least one molecule exhaled by Julius Caesar, and a few from dinosaurs, mastodons, and possibly a very surprised trilobite. Molecules don't get sentimental, they just keep cycling. The cycles themselves are the hidden machinery, the carbon cycle shuttling atoms between air, water, soil, and organisms, the nitrogen cycle feeding the proteins in your muscles and the chlorophyll in leaves, the water cycle tying clouds to glaciers, to oceans, to your glass on the table. Break any one of these and the design starts to wobble. Light joke 1. The nitrogen cycle is like a landlord. You don't see it often, but without it, everything collapses in a week. In photosynthesis, you see the elegance of molecular design. Light strikes chlorophyll, electrons jump into action, and suddenly carbon dioxide and water are rearranged into sugar and oxygen. That sugar becomes fuel for plants, and when you or any other animal eats the plant, or something that ate the plant, you're plugging directly into sunlight captured and stored in chemical bonds. If plants are the planet's solar panels, then you are running on batteries charged by photons. Respiration plays the counterpoint. You inhale oxygen, break down sugar in your cells, release carbon dioxide, and send it back into the air for plants to use again. It's a partnership older than any forest, older than any ocean current, a perfect loop with no boss and no board meetings. Scientists still debate which came first, photosynthesis or respiration. Did life learn to store energy before it learned to release it, or did the two arise together as partners from the start? It's a chicken and egg question, written in chemical script. Odd fact number 2, plants also respire. Even your most self-righteous houseplant takes in oxygen and gives off carbon dioxide at night. If it had a social media bio, it might read, "Making oxygen by day, breathing like you by night." The blueprint extends into geology. Carbon cycles not only through living things, but also through rocks locked away in limestone or released in volcanic outbursts. Silicate weathering slowly scrubs carbon dioxide from the atmosphere, regulating temperature over millions of years. Without it, Earth might have boiled like Venus or frozen like Mars, depending on which way the imbalance leaned. Light joke 2. Silicate weathering is the planet's version of a slow cooker, takes millions of years, but the results are worth it. Water chemistry shapes oceans into living landscapes. Dissolved salts, carried by rivers, determine the creatures that can survive there. Oxygen levels decide whether a bay will teem with fish or choke in algal blooms. Coral reefs, built from calcium carbonate, are as much chemical sculptures as they are biological wonders. They dissolve if the water grows too acidic, a reminder that chemistry has veto power over beauty. Odd fact number 3. The Dead Sea is so salty that you can float without trying, but its density means sound travels differently there. Conversations on its surface can sound slightly warped, like the water is editing your vowels. From your drifting height, you see invisible plumes, methane bubbling from wetlands, dimethyl sulfide from plankton blooms. pollen drifting like golden smoke. The atmosphere is not just nitrogen and oxygen. It's a cocktail with trace ingredients that shape climate, weather, and the sharpness of your next sneeze. Scientists still debate how much human tinkering the chemical blueprint can tolerate before the loops and cycles break beyond repair. Can excess carbon be scrubbed from the sky quickly enough? Can nitrogen runoff be reined in before dead zones expand across oceans? And will the fixes come from new chemistry, synthetic enzymes, carbon-storing concrete, or from old chemistry rediscovered, like the way wetlands filter water for free if you let them? Light joke 3. Somewhere, a wetland is listening to our climate plans and saying, "Cute, but I've been doing this for 10,000 years. You lower yourself to the scale where cells are whole worlds. Proteins fold and unfold, enzymes clasp molecules like careful hands, membranes pulse with ions like breathing. The same design principles appear again and again: efficiency, adaptability, feedback loops that stop processes before they run away. These patterns hum at every scale, from a mitochondrion to a mountain range. It strikes you that the planet's design isn't about symmetry or perfection, it's about persistence. Atoms keep finding new ways to assemble into life, and life keeps finding new ways to survive the atoms. The blueprint is less a fixed plan than an evolving conversation, written in a language that no single species owns, but all must obey. You rise one last time, letting the chemical loops fade into the wider frame until continents and oceans fill your sight. From here, Earth doesn't look like a puzzle to be solved. It looks like a breathing, shifting, shimmering work in progress, its design less like a blueprint on paper and more like a piece of music played differently each time. You see the molten beginnings still echoing in volcanoes, the first rains reflected in every lake, the microbe empires alive in every spoonful of soil. You see the Cambrian seas folded into the bones of birds, the green revolution of plants whispered in every lungful of air. The story is all still here, stitched into mountain strata, swirled into weather patterns, recorded in the quiet mathematics of orbits. Odd fact: if Earth was scaled down to the size of a basketball, the highest mountain and the deepest ocean trench would be barely detectable under your fingertips. Smooth to the touch, yet unimaginably diverse beneath the skin. Science fact: the biosphere, atmosphere, geosphere, and hydrosphere are in constant interaction. Alter one, and you inevitably alter the others. It's a living network, not a static object. Light joke 1. Think of it as the world's most complicated group chat, where every participant insists on talking at once, and somehow it still works. From space, cities sparkle at night, like spilled constellations. Oceans swirl in gradients of blue, deserts glow with heat, and the poles hold their pale crowns of ice. You know these patterns aren't fixed seasons, storms, and time keep moving the pieces. And beneath the visible is the invisible, the magnetic shield fending off solar winds, the deep currents pulling heat across hemispheres, the microbial collaborations that keep the soil alive. Scientists still debate whether a planet like this could arise often in the universe or whether Earth is a cosmic fluke. Some think that given the right ingredients, life and complexity are inevitable. Others believe the chain of events here is so specific down to the asteroid strikes and moon's tilt that it may be rare beyond measure. The answer remains unwritten, tucked somewhere between probability and poetry. Light joke 2. If Earth is rare, it's definitely the eccentric aunt of the galaxy, the one with all the strange stories and the garden no one else can quite figure out. The human place in this design is still young, still uncertain. You've learned to read some of its rules and bend others, to build within it and sometimes against it. You've altered its chemistry, rerouted its rivers, warmed its air. You've also restored forests, cleaned seas, and engineered ways to capture the carbon you've scattered. You're not the designer of this world, but you've picked up the pencil. In the end, you understand that design here doesn't mean finality. The Earth was never finished. It was never meant to be finished. Its beauty lies in its capacity to keep becoming. The continents will keep wandering, the climate will keep shifting, species will vanish and appear, and maybe, if the choices tilt toward care, the blueprint will expand to include a longer chapter for you, too. Light joke 3. In the meantime, try not to lose the instruction manual. Spoiler, it's written in tree rings, ice cores, and the stories your grandparents told about the weather. You watch clouds braid over the curve of the horizon, and for a moment it's impossible to tell if the design is fragile or unbreakable. Probably both. The fragility is what makes it precious. The persistence is what makes it endure. The music of it waves, wind, bird calls, and the low thrum of the planet's turning slows as you drift back down. You think of all the odd facts, the quiet processes, the accidental beauties. You think of deserts blooming after rain, of tides tracing the pull of a faraway moon, of rivers drawing maps no one asked them to, and you realize this is not a museum piece. It's a living gallery, and you are inside it. You settle into the silence with the sense that you don't have to hold the whole story in your head. The design is bigger than memory, bigger than language, and it will keep on, with or without you, but better with you. You have drifted from Earth's fiery birth through oceans, microbes, forests, extinctions, and the quiet reign of chemistry, tracing the design not as a rigid plan, but as an evolving masterpiece. The molten core still hums beneath your feet, its magnetic field shielding you from solar winds. The continents still wander, driven by deep tectonic restlessness. Oceans and atmosphere remain in conversation, carrying heat, nutrients, and storms. You've seen deserts and rainforests as equal partners in the blueprint, extremes that foster resilience. You've watched humans add their own layer cities, grids, and quiet innovations, sometimes in harmony, sometimes in tension with the older design. You've learned that life is stitched from stardust and sustained by endless cycles of water, carbon, and nitrogen. The debate remains: is this planet's complexity common in the universe or an improbable accident? The answer hides between the laws of physics and the poetry of chance. For now, Earth continues to write itself season by season, tide by tide, welcoming you as both witness and participant. So you rest in its care, knowing you are part of something vast, fragile, and ongoing. The design is not finished, and perhaps that's the most beautiful part. End of script. Good night.